Good morning, everyone. So we have the first panel of today. It's actually a very special panel. We've got our main stage sponsor up first, Invest in Canada. So I'd like anyone that's really interested in this panel, it is a special panel, to come and take your seats. I'd like to invite Laurel to the stage. Laurel is the CEO of Invest in Canada. I'm going to embarrass you a little bit, Laurel, so I have written a few things. I stalked you on LinkedIn. But Laurel is a multi-award-winning CEO with over 30 years' experience spanning public and private sectors, economic development, inclusion, environmental sustainability, fiscal regulation, and responsibility. But I'd like to invite you now to the stage to kick off this first panel of the day.
Thank you very much. Thank you very much. Good morning, everybody. As was said, I'm Laurel Broughton, the CEO of Invest in Canada, which is Canada's national investment promotion and attraction agency. I'm really pleased to open Canada's National Innovation Ecosystems Pavilion this morning and welcome you to a discussion about Canada's innovation advantages. Je suis Laurel Broughton, la PDG d'Investir au Canada, notre agence nationale de promotion et d'attraction d'investissement. Je suis très heureuse de vous accueillir aujourd'hui à la Pavillon national des écosystèmes d'innovation du Canada pour une discussion sur les avantages canadiens en matière d'innovation. Before we dive into this morning's conversation with our panelists, who I will call up to the stage in just a moment, let me tell you just a little bit more about this year's country partner, Canada. In my role as CEO of Invest in Canada, I have the privilege to talk to CEOs from all over the world as they evaluate where to locate projects. Consistently, I hear one clear message. Canada has what they are looking for when it comes to innovative projects. So let me tell you why. A key starting point is talent. When you invest in Canada, you access to the world's most highly educated workforce. This includes STEM talent, bolstered by deep R&D and industry-focused expertise. Grâce à ces talents exceptionnels et à une collaboration approfondie dans le secteur privé, les entreprises et les universités, le Canada a développé des écosystèmes d'innovation solides dans tous les domaines. Thanks to this exceptional talent and deep collaboration between the private sector, business, and academia, Canada has developed a very robust innovation ecosystem in everything from advanced manufacturing to agri-food and ocean technology. You will find a real depth of R&D support in Canada, including our world-leading colleges. Many of them are here in our Canada Pavilion. Renowned research organizations like the National Research Council of Canada, and industry-led innovation networks like NGen, the Next Generation Global Innovation Cluster for Advanced Manufacturing. We also know that many businesses are looking to reduce emissions. And in Canada, one of the key factors is that 83% of electricity is non-emitting, making it possible for companies to make their entire supply chains more sustainable. And if that weren't enough, Canada also provides exceptional market access through free trade agreements with 51 countries and is the only G7 country with free trade agreements with all other G7 countries. Through CETA, the Canada-European Comprehensive Economic and Trade Agreement, 99% of trade to 500 million Europeans from Canada is tariff-free. Regulatory certainty allows investors also to make decisions based on long-term success rather than short-term concerns, and supportive government offers true partnership. As a lawyer and former legislator, let me also emphasize something that I know is top of mind for many, many investors right now: stability. Grounded in the rule of law, fairness, and transparency, Canada consistently ranks among the most stable countries in the world. All told, Canada's value proposition to global companies is more relevant and more needed than ever before. And we know investors are taking notice. FDI in Canada hit $87.8 billion last year, its second highest total on record. Canada also ranks among the top countries for FDI inflows and maintains a top 2 position on the Kearney Global FDI Confidence Index, All things to celebrate and be very proud about here in the Canada Pavilion. Finally, let me speak directly to potential investors in the room to tell you that Invest in Canada is here to help. We can work directly with your company to guide you through the decision-making process from initial inquiry to project opening and beyond. We collaborate with Canada's Trade Commissioner Service in over 160 cities globally, as well as with federal departments, provincial and territorial governments, and local economic development agencies, again, many of who are joining us here in the Canada Pavilion. We want to ensure that Canada speaks with one voice when we speak to you, and we look forward to working with you to see you choose Canada as your second home. My team is here today and ready to work with you. Nous allons maintenant découvrir comment le Canada est un partenaire clé en matière d'innovation pour les entreprises globales. And now it is my absolute pleasure to call up my panelists this morning and to begin a conversation with them on innovation ecosystems in Canada. Andrea Engelin is Head of External Affairs and Government Relations for CellCentric. As a joint venture between Daimler Truck AG and Volvo Group, CellCentric develops, produces, and commercializes fuel cell systems. Now back in the Stuttgart region for the last 2 years, Andrea led the Canadian operations of CellCentric in Burnaby, BC for 3 years as CEO and CFO. Welcome, Andrea. My next panelist is Tanya Leppert, Chief Technology Officer of Ericsson Canada, with over 20 years of global experience across North America, Asia, and Europe. Based in Sweden, Ericsson has been investing in Canada for over 70 years, where the company has 33,100 Canadian employees, holds 3,900 Canadian patents, and has made an overall Canadian R&D investment in excess of $7 billion. Welcome, Tanya. I can't wait to get into this discussion with both of you. Well, good morning. Welcome. It's great to have a chance to sit here and talk a little bit about innovation ecosystems. So let me just ask both of you, and maybe I'll start with you, Andrea, to introduce a little bit more. I did my best at talking about CellCentric, but I know the amazing work that you're doing. So tell us just a little bit more about CellCentric and the journey, and then we'll hear from Tanya and we'll dig into more questions.
Thank you very much, and good morning, everyone here listening to the panel. I'm very happy to share some experiences I had when I was a CEO, and right now in my experiences with Canada. So, Lois, thank you also for the introduction. I'm Andrea, Head of External Affairs, and I used to be the CEO in Canada for CellCentric. I'm afraid not all of you know what CellCentric is doing. So CellCentric is developing and manufacturing fuel cell, hydrogen fuel cell systems, mainly for heavy-duty trucks. So we have some very specific situation. We have the biggest two OEMs, Daimler Truck and Volvo Group, being our shareholders. So these two companies together have more than 50% market share in Europe and also in North America. And if they join forces together to basically push and commit to the hydrogen fuel cell technology, that really sets standards for the whole technology. So this is very special. But also special for CellCentric is that we have not started from zero. CellCentric is a small company with about 600 people located in Germany and in Vancouver, British Columbia, Burnaby. And so the joint venture started in 2020 when I was a CEO there. My project was to set up the legal entity and also to build a new facility, our Advanced Development Hub. And I think that's for now a short introduction.
Yeah. Well, I'll just share with the audience that I've had the chance to visit with Cellcentric here in Germany and in British Columbia, and one of the most amazing things is seeing the innovation in the hydrogen fuel cells and the change in size from your earliest days of the size of the fuel cell to now. So we look forward to talking more about those innovations. Tanya, tell us a little bit about Ericsson and your journey.
So Ericsson's a Swedish company, and you mentioned already, I think there's 120,000 people globally. So I think we famously have operations in every country of the world. And we've been developing telecommunication networks for 145 years. And been in Canada for 70 years, actually. So we, in Canada, we have about 3,000 people. We do basically everything behind the cell phone. So apart from the cell phone, behind that, you have the radio access, you have a lot of the switching, the database subscribers and everything, security, privacy, those type of things. So that's what Ericsson is developing and providing to our communication service providers. So Deutsche Telekom, for example, is a big customer, Vodafone as well, of course. And so we've been doing this for over 140 years. In Canada, we actually have a lot of the whole portfolio. So we're contributing, you mentioned also the patents that we have in the radio access technologies. And some of the big things that we're working on now, of course, is AI, naturally. We all have to bring AI into our operations, but it is very close to the type of work that we do from a signal processing perspective. So looking at how we can use AI to optimize for energy performance as well, so sustainability is a big factor, and then security and privacy as well. So that's something that, as telecommunications and digitalization kind of permeate all of our lives, it becomes really, really important that we make sure that what we're developing and what we're putting out there is also secure for the people who are using it as well.
Great. Well, and not to not talk about a visit to Ericsson. I think that was my first week on this new job, being able to come and celebrate Ericsson's big new investments in Ottawa with you and your team a couple of years ago. And I know that at the time, the focus really talked a lot about talent. So I wanted to switch and talk to you about that. We certainly hear globally that it is a global race for talent, and we believe Canada, has a lot to offer when it comes to talent to innovative companies. So maybe if you can share your perspective on that.
Sure. So, first of all, Canada has a lot of really great universities, so there's a lot of the young talent that comes up, but also Canada is a really big immigration country, as we know. And I think that kind of diversity in the backgrounds and the competence and so on, that's what really drives innovation. So, Canada's a very welcoming place. Everybody is, welcome to be who they are, as they are. And I think it's, when you put those things together, that's where you come up with really great ideas.
Andrea, how about to you on talent? What was your experience with talent in Canada?
Yeah, so for us, when we decided to stay in Canada with the joint venture after being Mercedes fuel cell division first, it was really the people and the expertise that were in British Columbia. You might not know, but in Burnaby there is really the fuel cell hydrogen valley. This is a very special situation for Canada and worldwide. The expertise, one of the pioneers of fuel cell technology is Ballard, and we've been collaborating with Ballard for a long time as Mercedes, not as Cellcentric. But one decision at the time when we started the joint venture to stay in Canada was actually the expertise we have. And obviously we benefit from the students, not only in British Columbia. There are definitely lots of different technology center, universities, but all over Canada. So, and we bring also students from Germany into British Columbia. It's always a highly welcome opportunity for these young talents to also have international experience.
Great. Well, it is certainly something that in Canada we're really proud of. The talent, the inclusiveness, and the fact that we can, as a team that encourages folks to come and make Canada their second home, that we know that they will find a solid team and we'll help them do that. So thank you for that. I want to stick with you, Andrea, and talk a little bit about the future of mobility and the evolving nature of mobility. And not everybody in the audience has the privilege to see the vision that you guys talk about in terms of what the future of mobility would be. So maybe if you can speak more broadly, and then obviously with respect to hydrogen fuel cells, what is the vision for long-haul trucking?
I mean, every one of you is probably aware of battery electric vehicles, especially also passenger cars. But here I really want to mention the heavy-duty truck business. The hydrogen business can help decarbonize the whole world. Transport is currently globally having 7% of the whole carbonization, CO2 emission. So, and as I mentioned before, our two shareholders, they basically have more than 50% market share. So often people ask, why can battery not solve the problem? This is not possible because battery makes the heavy-duty trucks even heavier, so that is not the solution. And then also the electric grid is today not sufficient, and it will also not be in the future sufficient. So complementary to the battery, we really want to build the hydrogen fuel cell technology. There is application potential, and our shareholders really believe in the technology. So there's full support, so full commitment. We have lots of things to do, as you know. The hydrogen is not available everywhere, and we need the infrastructure. And this is what we are working on. That was the same with battery, and that was basically more than 100 years ago, the same when we had the first car running. The fuel you had to go to get in a pharmacy. So slowly we will go and build the hydrogen ecosystem, and we also have lots of support in Canada.
Great. Well, we can't not talk about evolution and innovation and not talk about telecommunications. So we're going to figure out how we're going to get our goods around the world. So that's what's happening here. But then we need to talk to each other and communicate. And you mentioned AI. 6G is the next thing that's being talked about. So when you look into the future, when Ericsson's looking into the future, share with us as your audience, what are you thinking about and what do you see on the horizon?
All right. So as you said, I mean, it's been like a lot of changes, and with the 140 years of experience, we've edited a few technology innovations. Of course, probably the one that's most visible is the switch from the public switch telephony system, which was wired, to mobile communication. Everybody has a mobile in their pocket, and now what we see is, and that's also why we're here at Hannover Messe, is like the integration of 5G into manufacturing and industries, because you get that reliable wireless communication between devices to the cloud, and that's how you get also the AI applications. AI is very data intensive, it's very energy intensive as well, so that's a lot of the work that's going into that also, to see how we can minimize the carbon footprint for that. And so that's also when we look towards 6G, that's also a big part of it, is like looking at how small we can get the devices and make sure that we're doing the processing in the most cost effective and energy efficient way possible. Then I mentioned before security as well, because as everything gets connected, there's a lot of data being transmitted, there's a lot of information being passed around and everything, so we want to make sure that we're doing that, you know, respecting the privacy, both of companies and of the individuals who are using the technology, so that's a really big focus right now for us. And then I think that the sort of last mile connectivity, so right now, you know, I mean, like where, especially like Canada's a good example, where you have a very large country, but the population is concentrated in some small pockets, so we're looking at how we can extend the coverage. And there comes the non-terrestrial networks as well, so satellite communication, where we can extend the communication so that you're able to even get coverage, you know, if you're out at sea or you're in the middle of a forest and so on. So looking at how we can also help, also, for example, public safety and defense opportunities as well for, if there's somebody who's lost in the forest or in the mountains, or, unfortunately we have a lot of forest fires, so looking at how we can help to coordinate the efforts when there's natural disasters and so on. So a lot about how communication can help society going forward.
Well, that's great, and I know that Canada will benefit from those technological innovations. How is Canada contributing to the development of those innovations for Ericsson?
So right now we have, as I mentioned, we have most of the portfolio actually being developed in Canada. So we have contributions, and it's a lot of international collaboration. But you mentioned NGen, and there's also NGen. So Ericsson is also participating in a lot of the local innovations to work with startups to see how we can develop the applications that will use the telecommunication infrastructure. So we're leveraging a lot of the local community in Canada to build out these applications, to try them out, to test them, to see how it works, to validate some of the use cases and so on. So that's also like one of the benefits actually of being in Canada is with that big ecosystem, we can really validate a lot, because telecommunications is it takes a village. So there's a really big village in Canada to help bring up that innovation.
Well, that's great. And I know that, obviously we are here talking about innovation. Innovation is the theme of Hannover Messe in terms of bringing the world together and talking about these focuses. So what has your experience been at Hannover Messe? Is this a place that you come annually? Just talk a little bit about, situate us. Why are we here at Hannover Messe talking about this? Do you want to start?
Sure, I can go. So we've been here for a few years as Ericsson, actually. Again, manufacturing is a really big part where we can see that the infrastructure and the communications can really help to boost productivity, help to automate, help to increase how much. Also, back again, energy efficiency is a really big topic, so I keep repeating that. But we've been here quite a bit to also raise awareness about what we're doing and so on. So I know that there's also Wi-Fi is also a potential technology for that. So we also look at the crossover between those, and it's really inspiring to be here and see all the companies and see what everybody's doing. Bit of a reflection is AI is absolutely everywhere right now, so I think that's something really to keep an eye on. There might be a bit of hype around it at the moment, but after every hype comes the real innovation that comes out of that, so I'm looking forward to that.
Great. Andrea, your experience. We're in your home country. We're hearing about, and it's lovely that Canada is the country this year, so it's been a fun combination. So tell us about your experience.
I totally agree with Canada being the host country this year. This is amazing. But as we are based in Germany, it is a must. It's not even a question to come here. And here in Hannover, all the people come together, right? And I don't know if you have experienced Hall 13. This is where also the fuel cell and hydrogen technology is demonstrated. And it has grown over the last years constantly. So this is amazing to see. And CECENTRIC, of course, cannot miss this opportunity to first of all connect with potential customers, with suppliers, with the government and ministries. So it is really the place to be when it comes to connecting.
Well, that's good. You've encouraged our audience after we speak, not till we're done, put their runners on and go to Hall 13. Except for being on the stage, I have had runners on all week because this is a massive site. But it has been enjoyable at times to get outside, have some fresh air, go into the next building. So we've done our best, but we've not covered all of the ground yet, that's for sure. So I want to switch gears and talk a little bit about the fact that you are both very familiar with Canada and global companies as they look to determine where they might next set up operations. And so I thought it would be interesting to just hear from each of your perspectives, because you've been part of some of those decision makings. What are the key factors that you would say to someone if they were saying, oh, you're in Canada, why should we be in Canada? Andrea, I'll start with you.
Oh, there are so many factors, and I have to say my answer will be totally biased because I've lived in Toronto. I studied in Toronto at U of T, and I lived 5 years in Vancouver, and I just love Vancouver. But for serious business, it is also a very good decision to go to Canada. I've been to the opening ceremony. I went to several other receptions here, and it has mentioned every single time. I mean, Canada is a very stable and reliable country. I mean, you have to mention that in these difficult geopolitical complex situation. So I think we share the same values. It has mentioned several times. But also, whenever I had business meetings with different, whether it was with the government, whether it was with you, customers or suppliers, it is always very respectful and still very natural. You can still, every once in a while, laugh, even though you have serious conversations, you talk about hockey. So that is also something which really sets the scene and makes it very comfortable. It was during COVID when I met Invest in Canada. We were in the middle of setting up a new facility in Burnaby. And during COVID, it made it extra special, extra challenging. However, with Invest in Canada, it was also the hidden little factors. And we had to get our building permit, and we were running a little bit late. But for us, it is really a lighthouse project, and we had to be ready on time. And it was with Invest in Canada and all their network to set the right priorities, connect us with the mayor, connect us with the fire department. It sounds a little bit not so important, but these are the little things that also count. And on the other hand, you're also going bigger again. You have funding opportunities. You have funding possibilities for research and development, for innovation. So I don't want to list all the ones. You have to connect with Invest in Canada. But also there are tax reduction programs which are really attractive, and hopefully you could benefit from it. So this is obviously very important when you start a new business to have funding opportunities. We talked about the talent, which is definitely available. And yeah, so we are very happy to continue our business there, and hopefully we are growing fast.
Great. Well, thank you for highlighting the work of our Invest in Canada team. What I would say to the audience is I really am very privileged to lead this wonderful team and to talk about Canada around the world and invite people to set up their operations in Canada. But we do more than just the invitation. We actually help with the nitty-gritty of getting things done. And I think that's the key factor, because when you're setting up in a new part of the world or in challenging times, you need those connections. And we always say our team is part of your team in terms of trying to make the connections that you need. If it's not us, we'll figure out who it is. Obviously, we're not the fire department, but we can figure out who's who and make those connections. And it's really important because we hear from companies large and small that it is challenging at times to figure out how to set up new operations. And so I would invite folks to make the decision to invest in Canada and then call on us to help. So I'll ask your same experience. Obviously, Ericsson's been there a long time, and some might say, you know, you really don't need help, don't need any guidance. But first of all, let's go back to the question, which was, what would you say to global investors about the experience? And then, you know, do you have any tips as to how they might succeed?
Sure. So I think, and Andrea mentioned as well, I think that the tax incentives program and the funding that's available to fund innovation, I think that has really helped a lot to keep the innovation going in Canada. So it's, and I think it's a testament also to what's available here when we're in the country for 70 years. So, but we, you know, that really helps to, you know, keep the ball rolling. Also, as you said, keeping the connections with the industry, because I mentioned before, like both diversity in terms of talent, but also diversity in terms of different industries and what type of innovation can come from that. So definitely those kind of connections, the funding opportunities, testing out, like if things are actually working. I think that's also like identifying those opportunities where we can actually try out different things. So we have, collaborations internationally with the companies like Airbus. Siemens could be a good opportunity. We were just meeting him yesterday. So I think there's a lot of those things where, the role as facilitator also to bring those ideas together, to bring the community together. I think that's been very, very helpful. And that also distinguishes us like on the global scale when we're looking at where companies are investing. So, in the initial phases, I think it's really supportive, but then also in continuing that innovation, continuing and the number of patents is a testament to that, right? So those are the kind of things that you can really help with and that we really appreciate.
I wanted to drill down a bit on R&D and science innovation. And you talked about, what's transpiring around the world. And I think an important part, Canada is a believer in R&D, supportive of R&D, believer in science, believer in and advancing, and making some moonshot, goals of trying to get society to certain places. So how important is that culturally when you're looking to drive the two organizations that you are part of, that folks believe in that and want to move R&D forward?
So, I mean, and that's also like, a company like Ericsson, 140 years, like it doesn't come with short-term thinking only, right? So long-term is really important. So it's, you need to be able to project into the future. You need to be able to set very ambitious goals and keep at them. So it takes a lot of perseverance actually to reach those type of goals. So I think, and that's, you mentioned before the stability of the country. And I think those are the kind of things that it's like when you look long-term at what you need to have and you look at, we talk about sustainability from like an environmental perspective, but also from a business perspective. So it's like, it's something that you want to be able to, rely on year after year, that is going to be there so that you're able to really reach those big moonshot goals. There's no way to reach them without perseverance and a lot of hard work. So
that's right. Andrea.
Yeah, innovation definitely needs money. So this is the first thing. And we talked about funding opportunities and tax reduction programs. So this is super important. But also, there's a reason why we, CENTRIC, decided, being in Germany and Canada, to have our advanced development hub in Canada and not in Germany. We closely collaborate together for sure. But while we are having customer trials in Europe, we are already working on the next generation to get even better in the fuel cell technology. So innovation takes time. You need to have a stable and reliable place to be in order to feel comfortable to do innovations, and this is definitely the place where we are right now. Yeah.
Well, it's hard and it takes time. So we're not quite at the end, but I want to pause and we'll both say thank you. Thank you for the work and the belief that you both have and your companies have in driving society forward. I think one of the most exciting things that I get to be part of is sitting down with leadership of companies around the world and hearing where they are trying to take things. And sometimes you can think we don't have solutions and it is not possible. But if you get an opportunity to sit down with people who are moving that yardstick forward and dreaming what is possible, it does make you realize it is possible if we all dig in and do that together. So I just wanted to sort of start coming to the close of our session here and offer you both an opportunity to, what message do you want to leave an audience that has taken time to come to Hannover Messe, that obviously has a lots of places to visit and people to talk to, but have spent a few minutes with us? Like, what is the most important thing? What are you hopeful about? What maybe keeps you awake at night, worried? Like, just share with us sort of what is your thinking on a daily basis about innovation? Big questions, I know. Big questions, I know, for the waning moments of a panel. But I felt that the audience really wants to hear this, so we're going to jump in.
So I'm, as head of external affairs, we see that there is a lot of things happening on a political side worldwide. And of course, this is slowing down investments, right? So being here now with Canada, being the host country of the Hannover Fair, shows even in these difficult times, we can stick together. unite and be stronger. I think it's challenging, but it's really also making us grow together. And for the audience, please visit us in Hall 13. And if you want to connect with me, I'm also here if you want to have any further details about our location in Burnaby and what was helpful to set up a business in Canada. I'm here for you. Yeah.
Thank you. Oh, Tanya.
Yeah. No, so I think key takeaways, there's a lot of technology innovation that's happening. I think it takes a lot of diversity and perseverance to achieve it. I think Canada is a fantastic place to be able to do that. I think what keeps me up at night is a bit like around the questions around security, cybersecurity. You mentioned also like the sort of evolving global situation right now. But of course, stopping innovation is not the answer. So it really is about doing it in a responsible way. So also invite you to come visit our booth in Hall 12 to visit Ericsson and see what we're doing there. Again, it's a lot about how we can use technology to benefit society, and I think that's really important, and that we keep that in mind. That we're also mindful of like the ways that it could, be perhaps detrimental, and that we're always putting things in place and continue to work on those things together. And again, together we can always solve those problems. So I think that's really important.
Well, I think that this is a great spot for us to end our conversation this morning, and we're not running away, so I too would invite all of you to talk to us, our team at Invest in Canada, about questions you might have, opportunities that might exist, and again, Dankeschön, thank you for joining us this morning, and thank you for spending time in a little footprint of Canada here in Hanover, and enjoy the rest of your day. Thank you.
Okay, we're ready. Ladies and gentlemen, if I could ask you to please take your seats. Prenez vos places, s'il vous plaît. I have, and I'm going to invite two very special guests onto the stage right now. My name's Jay Myers. I'm the CEO of Next Generation Manufacturing Canada. Good morning. Bonjour toutes et tous. Willkommen, meine Damen und Herren. Great pleasure to introduce, first of all, Mr. Phil Jennings. Phil is Canada's Deputy Minister of Innovation, Science and Economic Development. Phil, join me on stage. And it's a special honor to introduce you this morning to Germany's Vice Chancellor and Minister for Economic Affairs and Climate Action, Mr. Robert Habeck. Robert. I will give it back to you.
Oh, thank you. Thank you. Well, good morning, everyone, and he just gave me the microphone, so I think it's up to me to say a very warm welcome to Hannover and to Germany. Thanks to our Canadian friends, if I may say so, that you made the long journey, and thanks for staying a little bit longer in Hannover. When we discussed that Canada could be the special guest on Hannover's fair, and I spare my words about the fair, it has a long history, and I think it's the European industrial fair. It was at very different times. We came just in government, we visited the Chancellor and me, Canada. We established a friendship between the two governments, and when I say friendship, I really mean it with all my heart. It was such a wonderful cooperation with the ministers on the other side of the Atlantic. And now, in these times, I would say these bases that was laid 2-3 years ago is to be proven that this is also a political basis, because now, as I see it, Canada and the European Union are facing the same challenges, but answering on the same way. Meaning that the craziness of Donald Trump is answered with own strength. I see this in Canada and I really appreciate it. It's really parallel to what the European Union is doing, and I try to encourage the European Union to be tough on the Trump administration as well. So if you lay these both attitudes together, you see that Canada and the European Union match well together, and even better so maybe in the future. You have a value-driven democracy. We try to defend our liberal values in Europe as well. When I visited Canada 3 years ago or so, we discussed mainly climate issues, green hydrogen, creating a bridge across the Atlantic, talking about critical minerals and raw materials and digitalization and laying the work together. And I think this becomes more important now in these times, that the ones who believe in cooperation against isolism or protectionism, the ones who believe in open societies and liberal values have to cooperate. So I wish your industry a fruitful visit here in Germany, in Hannover and in Europe. Make some B2B meetings, make the best out of it. On the political side, I would say the future for a true Canadian-German, Canadian-European partnership has just begun. Thank you very much.
Thank you. Minister, I know you're a fan of Canada, you're a fan of our national sport, and of course in ice hockey there's a saying, and every Canadian is talking about this today, elbows up. So we also know when you're in a tight situation in the corner, we can count on your fellow team members to come in and get you out. So thank you so much for that. And we wanted to present you with an official Team Canada jersey today.
Shall I take it on? I'll leave it on.
No, it looks great.
Can I have the microphone?
So there's the mic.
This might be my last Hannover Fair for, well, at least for now, I say, because we are having a new government and I won't be part of it. So maybe I leave the tricot on just to give it a colorful ending. Thank you very much. Thanks for the tricot.
Hi, everyone. That was a fantastic interlude just before our next session. We have got Gillian Chatton, he's a manager of internationalization from the government of Newfoundland and Labrador. I'd like to welcome Gillian to this session to kick us off for this, this next pitch session. So, Gillian, please welcome to the stage.
Thank you. I need that mic.
You need that one.
Yeah.
Good morning, everyone. Bonjour à tous and Guten Tag. My name is Gillian Chapman, and I'm the Manager of Internationalization from the Government of Newfoundland and Labrador. Welcome to the Atlantic Canada Solutions Spotlight. The goal of these pitch sessions is simple: to connect Atlantic Canadian businesses with potential partners, investors, and industry leaders who can help them scale, expand, and make an impact on global industrial stage. Before we jump into the pitch sessions, I would like to welcome Kaylee Hatt-Kilburn, the Vice President for the Atlantic Canada Opportunities Agency, also known as ACOA. This is a regional development agency dedicated to promoting economic growth in Atlantic Canada.
Thank you, Gillian. Good morning, everyone. Bonjour à tous. Guten Morgen. Thank you for that lovely introduction. I'm very excited to be here today at this amazing Canadian Ecosystem Pavilion here at Hannover Messe 2025. C'est un honneur d'être ici parmi vous, parmi un groupe d'innovateurs assez impressionnants et des chefs de file d'industrie. Aujourd'hui, nous célébrons vous, les entreprises, qui représentent le Canada Atlantique ici au scène mondiale. Today, we celebrate our Atlantic entrepreneurs, the companies that represent Atlantic Canada on the global stage. And what a stage this is. Hannover Messe is the world's leading industrial event. And when you walk the floor, it's easy to see why. This is a place where groundbreaking innovation meets global opportunity. And just being here is no small feat. It's a testament to the hard work, the vision, and the commitment to pushing boundaries that each of these companies have. Atlantic Canada has long been known for its resilience, but increasingly we're becoming known for our ingenuity, and these companies are living proof of that. They represent a region that is bold, forward-thinking, and building thriving industries like clean energy, advanced manufacturing, and robotics. So this is a diverse group of entrepreneurs and solutions providers, and each of them is a shining example of the momentum that's building in Atlantic Canada. They bring new ideas, they're embracing cutting-edge technology and providing Atlantic Canadian companies and institutions with the solutions that not only our region needs, but that the world needs. So to our entrepreneurs that will be pitching here, gear up, get ready. Your pitches today are a chance to spark interest, forge connections, and open the door to something bigger. This is a true opportunity. Investors and industry leaders are looking for the next big thing to help solve the real challenges that their industries face, and I have no doubt that they will find some of those solutions here today. As you share your stories, your technologies, and your ambitions, you're demonstrating to investors, industry leaders, and global partners that Atlantic Canada is a place of opportunity, of collaboration, and of world-class expertise. So on behalf of the Atlantic Canada Opportunities Agency and the Government of Canada, I want to congratulate you on you being here and all of you've accomplished to reach this point. Your work is laying the foundation to demonstrate the incredible things that we're accomplishing for our region. So bonne chance, good luck, and thank you. Danke.
Thank you, Kaylee, for the introduction. Over the next 45 minutes, you'll hear from some incredible Atlantic Canadian companies as they deliver 4-minute pitches highlighting their groundbreaking technologies, unique value propositions, and key opportunities for collaboration. Each presenter will have just 4 minutes to share their story, and we ask that they stick to this time as we want to hear from everyone. Kicking off our session, I'd like to invite Martin Simic from AKA Energy Systems in Prince Edward Island to take the stage.
Thank you, Jillian. AKA Energy Systems. We are an electrical systems integrator. We're based in Prince Edward Island in Canada. And what we do is we look for the best possible technologies that are out there in the market and try to find ways to integrate them into comprehensive solutions for our customers. We have an extensive capacity in engineering, electrical, mechanical, automation. We have our own machine shop, electrical assembly. We can do our own testing with a fairly advanced testing bay infrastructure. We do our own installation and commissioning, and we provide lifecycle support to our customers. Our partners, shareholding partners, are Transocean. It's a US company based in Houston, and MAN Energy Systems, a German company based in Augsburg. Inevitably, every project that we work on touches on these three elements, and these are the outcomes that we provide for our customers. We increase the reliability of their processes, of their power plants, by reducing the cognitive burden that goes into operating these assets. We make their operations more efficient, and nevertheless, we also reduce their environmental impact. For the first 25 years of corporate life, we were working exclusively for our customers in a marine environment. Offshore oil and gas, merchant marine, passenger vessels, special purpose vessels, and so forth. And we were delivering are delivering some of the more advanced power plant systems and energy management systems for these sorts of assets. And then we looked at the land-based industry, and we realized that our technologies and our solutions that we developed for marine are very much applicable to land-based microgrids as well. We partnered with companies like Bosch and are delivering modular microgrid systems that can take communities and industrial base not only towards a sustainable future, but also create energy, provide electricity in a sustainable way. And nevertheless, we're developing our modular systems for delivering e-fuels from hydrogen to our customers as well. On the back of the investment in technology, in our projects and so forth, we have developed a very comprehensive testing infrastructure where we can test our technologies in a very sort of integrated way. And we looked at that and we realized that this is not only an asset that's important for AKA, but also an asset that's important for other participants in the clean tech sector. We created a nonprofit arm called EcoFusion Testing Labs, and we're making these assets, this testing infrastructure, available to our clean tech partners, not only on PEI, also in Canada and globally. So if you're interested to talk more about that, please contact me, and I'm happy to continue the dialogue on this. Thank you very much.
Thank you, Martin, for the great overview of AKA Energy Systems. Next up from Newfoundland and Labrador, I would like to introduce Pascal Millord, Project Manager with Atlantic XL.
Right slide. Cover's wrong. All right, no worries. Hello, how you doing? I'm Pascal Millord, Project Manager for Atlantic XL. We do additive manufacturing, advanced engineering in St. John's, Newfoundland, Labrador. So Atlantic XL was established over 25 years ago, providing communications, navigations, and power systems. The newest division was established about a year ago, a little over a year ago, and we provide advanced engineering design and additive manufacturing services. We service multi-sector, So we're not any particular sector. And let's get into this. All right, so the company itself provides us front-end engineering, so we do 3D scanning, precision 3D scanning. We also provide the first metal additive manufacturing 3D printer in Newfoundland, Labrador, and one of the few commercially available ones in Atlantic Canada. Amongst that, we do precision design and re-engineering of parts and components. And we do simulation as well as polymer prototyping. And we also have heat treatment and post-processing. So what value does this add to the region? Some of the challenges we see in the industry are lead times, high up there. Lead times of remote operations. So it's a remote region. We have offshore assets. We have mining sites up in northern Labrador, for example. So we support kind of the remoteness and the challenges with the supply chain there. A lot of parts we see in several assets are very old. We're talking 50 years old, sometimes 100 years old. No drawings, nothing in existence. There's also a spares inventory management. Oftentimes, say for example on a rig offshore or on a mining site, you have warehouses full of spare parts, and oftentimes 80% of these items are simply discarded at the end of life. So you're paying for warehousing, you're paying for parts that you never use. Equipment failure is also common. Parts wear out, whether your part doesn't exist anymore or is a common failure mode. We can certainly look at that. And obviously getting raw material, getting parts shipped to remote locations such as Newfoundland and Labrador and or anywhere else in the world is always a challenge. So what are the solutions here? Well, in terms of our case, we're on the very, very east coast of Canada, and that provides logistic challenges for getting parts in. So we're able to make parts in situ in the region and provide in a very timely manner. We can take parts and recreate them, and we can also enhance the design if there's issues with the design as well. And of course, all our parts would be in a digital warehouse, so on demand. So if a client comes to us with a part, we can simply have it warehoused in a digital inventory and able to produce it. We're also part of some nodal networks in the world, and we are a node of local capacity. So if, for example, a ship was in our region, we could have an order from Germany come in to Newfoundland to repair a part on a vessel and or a asset. As well with some of the failure modes we're seeing, we can enhance our designs. So not only in legacy design, but we can also optimize designs with generative AI and different things like that to create lightweighted designs and optimize thermal management and things like that. And of course, everything being localized, we're reducing emissions significantly, and it's a local sustainable solution. Where we use powder in our manufacturing, it's just constantly reused. So you're only using about 2 to 3% of your powder during a build, and we recover that powder and use it over and over and over. So it's a very efficient method of production. That is it for me. Thank you very much.
Excellent. Thank you, Pascal, for telling us a little bit about Atlantic XL. And next, I'd like to invite Armin Strobel, CEO of Strobel Tech in Newfoundland and Labrador, to the stage.
Thank you, Julian. Yeah, so I want to start off with a short introduction of myself and the company. So I'm actually originally from Germany, lived since 14 years in Canada. And I have worked on drones, where they were not even considered to be drones, since over 23 years, 2002, something like this. Or starting with the target drone, Dornier DT-25 and, no, 35 and 55. So 25 did already exist in production. Yes, and I have an aerospace PhD in swarming of drones. And yeah, that's regarding myself. The company was founded in 2017 We have a special drone system which is based on a ducted fan design. So the drone takes off from its docking station, does its job, whatever it needs to do. There's different applications. You might get an idea of what applications we're mostly focusing on. So the drone takes off, does its job, then the operator doesn't need to care about how to come back. It just tells it either to go back or end of the mission. It automatically comes back to the location of the docking station, gets into the docking station and gets recharged. So there's no human interaction at all necessary, on site especially not. So it can be either remotely operated or it can be actually on site. Let's say you're in an armored vehicle and you don't want to leave for a specific reason the vehicle, then you can actually operate it from within a vehicle. Another advantage of the system is that you basically need no training, almost no training. Anybody probably of you guys here, within an hour train to operate that system. And then you know it really well. So you probably, most of the people, 5 minutes and it was all fine. Yeah, we see it. Actually, I mean, I don't even need to talk about it. It's just a video. But that was actually a project which we did with Rheinmetall Canada together. And yeah, we have another drone system which is derived from it. That's the Sprinter 100. The purpose of that system is to be really quick, and one of the applications is actually to intercept other drones. We stopped here the drone actually to intercept the other drone because it gets quite costly after a while. So we actually do lots of dry runs and stuff like this, and you see actually that's one of the nice shots where you see actually the drone flying. Also, there you see actually the flight mechanics of the vehicle is basically similar to a rocket. So we have actually our missile. Yeah, and yeah, what we're looking here is actually for, and you get some technical data here. What we're looking actually for is potential partners in Europe or in Germany or other neighboring countries. And yeah, that's from our side. Any question?
Thank you. Thank you, Armin, for showing us your drone technology. Next up, we have Bill Butler, who's setting up his demonstration, and he's the president of Oil Filtration Solutions, also in Newfoundland and Labrador.
Thank you, Jillian. Hi, everyone. I hope everyone's doing okay after the event last night. Got a good night's sleep. So, ladies and gentlemen, I'm from Conception Bay South, Newfoundland and Labrador. We're the far east of the Western world. And I'm going to speak to demonstrate our oil recycling technology. Industry requirement, everything is lubricated. You're talking transmissions, diesel engines, hydraulic systems, turbines. And the need to change the oil is frequent due to contamination. So what we do, actually, we recycle oil while it's in use. And to demonstrate that, I'm going to contaminate our reservoir with photocopier carbon and oil. Standard oil filters on equipment are generally rated for 25 microns. Your hair is 75 microns thick. So what happens is, over a period of time, the oil gets contaminated. During that process, it causes mechanical wear, forces the individual to change the oil or risk mechanical failure. So firstly, we're going to run the oil through the 25 micron filter. And I can literally let that run all day. This technology cannot remove the contamination. As you can see. But our filtration technology, our element is 1 micron absolute, which means we can easily remove the contamination missed by traditional conventional oil filters. Our customers experience a 50% reduction in oil maintenance costs. I have customers that have gone 40 and 50,000 hours between engine rebuilds instead of 20,000. The technology was invented to reduce mechanical wear. I've been doing this for 23 years. It's just that today, with the need to reduce oil consumption, it is now looked upon as a green technology. We also do diesel fuel applications as well. We have mobile filter carts for, these are actually used in wind turbine applications. And we also have oil monitoring devices. This device can read oil temperature, oil pressure, viscosity, sludges, oil factor, cleanliness factor. We have a SIM card. The data can be received on any smartphone, laptop, or computer. So for wind turbines, it'd be very beneficial for the operator. Could be 1,000 miles away, can see what oil temperature. If your temperature's rising, you could have trouble with your bearings. If you've increased in water contamination, you know you've got an issue with your hydraulic system. So we are looking for distributors or end users, Northern Europe. We actually have somebody in Germany that's distributing our technology, but we're looking for potential partners for development, Northern Europe, Scandinavian countries, Caribbean. We have a distributor in the Faroe Islands, Mesh Shipyards, and we're throughout Canada from coast to coast. Thank you.
Thank you, Bill, for that great demonstration. And now for the last pitch from Newfoundland and Labrador, I'd like to call Rudy Roberts, Electronic Systems Manager from CompuSalt Limited, to the stage.
Thanks, Jillian. As she mentioned, I'm Rudy Roberts. I'm from CompuSalt Limited, Newfoundland, Canada. Our company has been around for 40 years. Longer than I've been alive. No, I'm kidding. I wish I was. So we're based in Newfoundland, but we have offices in Halifax. We have a U.S. subsidiary in Western Virginia, and we have an office in The Hague. We are geospatial. Our biggest products is called our Web Enterprise Suite, which is geospatial web portal that we use. Web Enterprise Suite is a geospatial web portal that we've been using to use for clients in U.S. military, Canadian military, and different government. We basically do big data solutions for these partners where they can introduce all of their geospatial products, whether or not there's imagery, maps, spatial coordinates. And why is this doing that? And so we can use that, and the different military and government partners can gather that data, whether it's in the field, through a mobile solution or whatnot. We have lots of expertise. We have lots of programming expertise in Canada and the EU and US. We have the ability to handle lots of data, and we have lots of solutions for mobile apps and GIS solutions. My forte is robotics, so we also have a line of robotics called Nanook. They're an uncrewed ground vehicle. These uncrewed ground vehicles can be used autonomously to perform missions in the field. We can give the vehicle a mission to go to a specific GPS coordinates. It will navigate there autonomously and be allowed to perform whatever functions, whether or not be gather sensor data, do surveillance, or whatnot. We also collaborate with other cobots, whether it be robotic arms or drones like Armin's Strobotech's drone, and for different monitoring solutions. So you see here, this is Nanook. Nanook is our uncrewed ground vehicle, and we've done different solutions around the coastal monitoring sphere, and all the data we collect from our UGV and the different systems can go back tied into our Web Enterprise Suite GIS solution. and it can be used for incident management for whatever solution you want to be. If there's a crisis, you can get all the data to come in from whatever you be and overlay it for incident management. Thank you.
Actions on your slide. I thought they were there intentionally, so I didn't do anything with them. Yeah. Thank you, Rudy, for telling us a little bit more about CompuSalt Limited. Now we have two academic institutions from Nova Scotia. First up is Dr. Jean-François Bousquet, a professor at the Department of Electrical and Computer Engineering at Dalhousie University.
Thank you, Gillian. Thank you, everyone. Hello, bonjour, guten Tag. Thank you to all my co-presenters this morning. They were all very interesting presentations. I'm here as a representative of Dalhousie University, which is the #1 post-secondary institution in Atlantic Canada. In Canada, we are a member of the U15 research universities, which also includes, for example, University of Toronto, as well as University of British Columbia. Oh, okay, I'm sorry. So big green button. Okay, so this is us. So as Gillian was mentioning, I am a professor in the Electrical and Computer Engineering Department and the director of the Microelectronics Innovation and Design Innovation Hub at Dalhousie. My colleague, Professor Sunil Nanda, is also here to represent our university, and he will help you drive your business value on waste-to-energy conversion technologies, green hydrogen production, social dimensions of resource and environmental sustainability. This is very important because of Canada's net zero emission target by 2050. Green energy solutions are emerging as a key priority at Dalhousie, and this includes for sustainable batteries and biofuel. Through the province of Nova Scotia's leadership and in partnership with Germany, our objective is to accelerate the shift from petrochemical solutions to hydro-based biofuels. I'm sorry. So at Dalhousie, our key research areas include clean tech, food security, innovation and entrepreneurship, as well as big data. These are all sectors that would be of great interest to the community in this audience. Dalhousie has 20,000 students. These are all sectors, and Dalhousie has 20,000 students and has an annual revenue of $258 million in research funding. So because of that, we feel that we have the right resource to partner with our German partners. So to focus a little bit more on the Mindy Hub, it's a new initiative that can support businesses through our broad expertise in integrated circuit design. This includes the development of real-time digital signal processing system, on-field programmable gate arrays, and we're particularly focused on ocean technology, biomedical applications, software-defined radios that can be applied to agriculture tech, aerospace, or other 5G wireless communication systems. In the field of analog and mixed signal circuits, we have expertise in the development of components for sensors, including phase lock loops and data converters in CMOS technology. With this expertise, we can develop new RF wireless, fiber optic, low power audio, as well as a broad range of sensors. We also have recently developed an expertise in quantum magnetometers. Our approach relies on Josephson junctions and superconductive quantum interference devices. With a startup company, we're assessing the feasibility of using the devices at high temperature, above 77 Kelvin, which allows to reduce the cooling costs significantly. We have a specific expertise in the electronic design, the modeling, and the control and interface of the circuit to produce voltage responses that will be read by the external circuitry. Over the past 2 years, we've developed the electronic models fabricated the device and tested it in control conditions at 4 Kelvin. We're applying this technology to the ocean sector, specifically for underwater navigation, positioning, anomaly detection, and wireless communication through the ice. So we want to thank you for your attention, and we'll be very happy to meet you to provide more details. Thank you.
Thank you, Jean-Francois, for sharing the interesting research underway at Dalhousie University. And finally, I'd like to call Dr. Wayne Grosco, applied energy research scientist from Nova Scotia Community College, to the stage.
Thank you. Hello, everyone. Bonjour. Guten Tag. I'm Dr. Wayne Grosco. I work at NSCC. The Nova Scotia Community College is a technical college. We cover the entire province of Nova Scotia, Canada, with training in trades, technology, business, media arts, all sorts of wonderful things. But did you know that we have a secret department? But it's not going to be a secret anymore because I'm going to reveal it to the world today. We have an applied research department. There we go. What does our applied research department do? We work with a lot of startup companies. We work with organizations, funders, and we bring the ideas that come out of those wonderful labs through that middle step that leads eventually towards commercialization. So what we help a company do is make that first prototype, do the proof of concept, move towards a minimum viable product, get something that you can put on that investor's desk or on that funder's proposal. That's what we do. So we're right there in the middle. We do research that is driven by the demand. So companies ask for what they need help with, and we give that help. We work in partnership, and many of our fearless agents are cleverly disguised as students, so they can sneak up on the competition. It's a model that works fantastically well. We work in 5 basic areas: energy, engineered technologies, agriculture, mapping, and artificial intelligence. I happen to be the leader of the energy team, so I'm hanging out in the energy hall all this week. This is a model which I will skip over of how we do our work. Come and talk to me about it later. We have infrastructure available. We have a research vessel, we have labs, 3D printing capability, 3D CAD design, electronics development, all sorts of ways that we can help companies and organizations. And a few quick facts. We have helped hundreds of projects move to fruition. Think of us as your skunk works. The people who will help ask and answer the question, how is this going to work in the real world? That's where we exist. So come and talk to me if that's what you're looking for. Thank you.
Don't turn on, because I don't know how to turn on. Many thanks to Wayne from Nova Scotia Community College for that wonderful overview. And we got to be the first to hear about his announcement. And finally, thank you to all our presenters for sharing your incredible work. A final round of applause for everyone. I encourage you all to continue the conversations, connect with our presenters, and explore how we can collaborate to drive innovation forward. Before we depart, I want to invite all participants to come on stage for a group photo. Enjoy the rest of Hannover Messe, and we look forward to seeing the impact of today's connections. Thank you for joining us. Maybe I'll leave this stuff here for now.
It's done. It's done.
Check this out. We're just gonna move this. Okay. I'm gonna move. Oh, thank you for that. I can't anymore.
Canada flag.
introduce Stefan, and Stefan will take it from there. Okay. So very quickly, I will introduce. Hello everyone. We're up to our next presentation now from Alberta Innovate, and it's called Advanced Materials in Alberta's Manufacturing Sector. And I'll invite Stefan Zuberek, who is the Technology Development Advisor at Alberta Innovate, to take the floor. Okay, you have one already. I have a mic, so just turn it on here? You don't have to turn it on. Okay. Normally.
Hello? Is it on?
Yeah, it's on.
Okay.
I'm going to go to the other side.
Good afternoon, everyone. Thank you for attending today's panel discussion about Alberta's manufacturing sector, enabling innovation and integrating emerging industry technologies across industries. Alberta Innovates is a provincial crown corporation, and we provide funding, business advice and connections, applied research and industrial testing facilities to accelerate research and innovations that benefit Albertans. The use of advanced materials has been identified by the Alberta provincial government as a priority to increase the competitiveness of Alberta's manufacturing and resource sectors, grow new provincial industries with export potential, and reduce the carbon footprint of material supply chains. The focus is on advancing technology solutions that create low emissions products, including plastics, concrete, food, wood, carbon materials, chemicals, and more. Now, to start our session this afternoon, I would like now to introduce you to Minister Matt Jones from Alberta's Ministry of Jobs, Economy and Trade. Minister Jones.
I got all of it. Okay. This, I'm not sure. There we go. So it works. Hello. My name is Matt Jones. I'm the Minister of Jobs, Economy and Trade for the province of Alberta, Canada, and it is an honor to be here with you. Before I get started, I want to thank Alberta Innovates for organizing this event, and I want to thank all of you in the room for attending this roundtable. I'm looking forward to hearing about the future of the energy transition and the role of artificial intelligence in building economies, as well as sharing Alberta's expertise in these important areas. It's also great to be in Germany with our Alberta delegation. Germany is a priority market for Alberta, and we have over 50 companies from Alberta at the show this week. Alberta is focused on strengthening its trade and economic relationships with Germany and across Europe. And in this time of global uncertainty, it's more important than ever that we work together to build on our mutually beneficial relationship. We want to leverage the Comprehensive Economic and Trade Agreement, or CETA, between the Canada and European Union, which has resulted in about 99% of EU tariff lines being duty-free for Canadian goods. Alberta and Germany already trade nearly $1 billion last year in 2024, and thanks to agreements like CETA, there are additional opportunities to expand on that success. In Alberta, we are constantly striving to achieve a balance of affordability, security, and sustainability across all sectors, but particularly in energy. Recognizing that to do so, we need to leverage new technologies and innovations. We also understand that innovation is the key to economic growth and diversification. To support our work in the technology and innovation space, our government established Alberta Innovates. This is an agency that works with researchers and innovators across the economy, and it supports our province's efforts to drive entrepreneurship, applied research, commercialization of cutting-edge technologies, and beyond. Alberta Innovates is also a key partner in implementing the Alberta Technology and Innovation Strategy. This strategy has allowed us to position Alberta as an international hub for technology and innovation. So we've got investments like Linde advancing a $2 billion clean hydrogen facility. Air Products is developing a net zero hydrogen energy complex. Shell and ATCO's nPower is advancing a CCS, a carbon capture and sequestration or storage project to store significant CO2 emissions. In fact, we've already stored over 14 million tons in our 2 commercial scale projects in Alberta. And Deep Sky, which is establishing the Alpha Direct air capture test facility to develop technologies to remove CO2 directly from the atmosphere. When it comes to energy production and innovation, Alberta is a global leader. We are helping to solve the world's most complex energy issues. And we're using some of the newest and latest technologies to do just that. So we use drones, for example, to monitor pipeline integrity and sensors to detect fugitive emissions. And we are also home to the Alberta Machine Intelligence Institute, or AMI, which is a global artificial intelligence leader. AMI has partnered with over 300 companies and is helping to drive solutions across economic sectors, including energy. And in fact, their technologies are supporting energy producers to reduce waste and achieve our sustainability goals. Time and time again, companies are choosing Alberta because of what we have to offer in technology and innovation. It also helps that we have a competitive tax regime, business-friendly policies, and one of the youngest and most highly educated workforces in the world. We also have an abundance of natural resources, which you've likely heard about. This means companies can continue to invest with a high degree of confidence, and we work closely with our industry and post-secondary institutions, which you'll hear from today, to build research and development pipelines that support advancements in all areas. So I encourage everybody here today to stop by the Alberta booths, where you'll meet some of the 50+ world-class companies that are sharing their innovations, products, and services. And with that, I'll turn it over to Stefan, who is the technology advisor from Alberta Innovates, for his presentation.
Thank you very much. Thank you very much, Minister Jones.
Thank you.
I'd now like to introduce you to our esteemed panelists for today's discussion. So immediately on my left, from Red Deer Polytechnic in Red Deer, Alberta, Debjyoti Sen, Director, Centers for Manufacturing and Energy Innovation. With a master's degree in mechanical engineering from the University of Alberta and a strong background in applied research, Debjyoti brings extensive experience bridging academia and entrepreneurial endeavors to his role as the Director of the Centers for Manufacturing and Energy Innovation. Debjyoti founded 2 technology ventures which helped entrepreneurs, small, medium-sized enterprises, and large industries in the adoption of a digital technology solution. He has a deep-rooted belief in Alberta's potential to thrive in advanced manufacturing, energy innovation, and digital technologies, and sees institutions like Red Deer Polytechnic Centers for Manufacturing and Energy Innovation as linchpins for propelling technological advancements and nurturing a thriving innovation ecosystem. Welcome.
Thank you.
In the middle, from the University of Alberta, in Edmonton, Alberta, Andre MacDonald, Professor of the Department of Mechanical Engineering, immediate past Associate Vice President, Strategic Research Initiatives and Performance. Dr. Andre MacDonald is a professor in the Department of Mechanical Engineering with more than 20 years of experience in the manufacture, fabrication, development, and performance assessment of thermal and cold sprayed coatings. His current research involves the development of multifunctional coatings that provide wear and erosion resistance, heating, and structural health monitoring to a variety of structures. Throughout his career, Dr. MacDonald has received several coveted awards and holds professional engineer licenses in Canada and the United States, as well as being a registered chartered engineer in the United Kingdom. Dr. MacDonald has trained over 100 students, fellows, and research associates in the areas of thermal spraying and heat transfer, and currently leads the experiential learning in innovation, technology, and entrepreneurship program for Black youth, a collaboration to support hands-on learning and work-integrated training of Black youth in the STEM field. And on the far end of the stage, from AMI, the Alberta Machine Intelligence Institute in Edmonton, Alberta, Stephanie Enders, Chief Delivery Officer. Stephanie Enders is a recognized leader in AI adoption and commercialization, serving as the Chief Delivery Officer at AMI. With a focus on responsible AI and open source strategies, Steph drives the transformation of advanced AI research into practical, ethical applications across various industries. She leads initiatives that enhance AI literacy, promote industry adoption, and nurture talent development, all while ensuring that AI technologies are accessible and beneficial to society. Steph's unique ability to translate complex AI concepts into actionable strategies has made her a prominent voice in discussions on AI's role in the future. Welcome, panelists.
Thank you.
So our format this afternoon is a series of questions where each of the panelists will be able to provide their perspective and then have some discussion amongst themselves. For our first question this afternoon, Could you please discuss the role of new materials, such as composites, nanomaterials, and smart materials in advanced manufacturing techniques? And if I could ask Andre to go first.
All right, thank you very much, Stephen. Just making sure that everyone can hear me in the back as well. So I would say that we're at a very exciting stage right now in terms of new materials that will feed into advanced or even additive manufacturing. And that excitement really comes from a place of wanting to create materials that are durable, that will last long, and that will actually survive and perform in extreme environments in many different applications that we'll see. So, for example, some of the things that that are coming in online right now are materials like high entropy alloy-based materials or high entropy oxides, for example. These materials have wonderful grain refinement from the material perspective. They have ultra strength that can be used for a variety of different types of applications. And they're actually one of the newer, breed of materials that are actually coming online from an alloy and from an oxide perspective. So think about a lot of these materials as being used for additive manufacturing processes to make freestanding parts, for example, and those parts actually having ultra-high strength to resist extreme conditions that you might see in the environment. Another area to think about are composites. That's another very exciting area. So fiber-reinforced polymer composites have been around for a long time. But what has been happening, in recent research and in new materials development is that metal matrix-based composites are starting to come online, with folks integrating things like graphene into metals, into matrices, that will enhance things like tribological performance, wear performance, if you're looking at things like landing gears for aircrafts, for example. So some really interesting applications are coming out. That also supports areas of repair, where you hear about things like remanufacturing, where we need new materials that can actually be resilient in extreme environments, in applications similar to what you would see for the Roth material or the original base material that you might actually experience. Another area that's coming online, and this is something that I'll definitely want to celebrate in Alberta, are companies that are actually using bio-based materials to support the creation of composites that can be used in the construction industry, in the automotive industry, for example. And this is Alberta creating materials that can be used across the country and internationally as well, which is a very positive thing. This is good because, as you may see from just being here at Hannover Mess, lots of folks are talking about sustainable materials. So given that Alberta's second economic driver is actually agriculture, we're actually creating a circular economy by pulling in agricultural bio-based materials into manufacturing processes to create new parts that are themselves durable, long-lasting, and will be able to perform in the field in various applications. And of course, finally, as a last point, one of the things that from a materials perspective that we're seeing as a research area and a new materials area are of course smart materials. So in that case, we're talking about materials that can actually do more than just provide passive protection or just be a mere part in a large ensemble system. So we're talking about materials that can do something. They're functional. Maybe they are a part that can generate heat. Maybe they are oxides that can be used in solar collectors, for example, or be used as catalysts for hydrogen production in renewable energy systems. So that's where we're going right now with new materials. And as the editor-in-chief of a top journal, the Journal of Thermal Spray Technology, I actually look for those kinds of papers because that's what's actually driving technology, that's what's driving new materials development, and then incorporating them into manufacturing parts to again make durable, long-lasting, resilient materials that will actually be something that will create an economic driver, not only for the province, but also for our partners internationally as well. Thank you.
Thank you, Andre. Deb Jody, what are the role of new materials in advanced manufacturing techniques?
Thank you for asking that question. Advanced manufacturing plays a big role in developing as well as applying how new materials gets created. So our centers for manufacturing, at Red Deer Polytechnic, we focus more on applied research rather than fundamental research. So we work very closely with the industry to understand what is the need of the industry demand, where the industry is heading in terms of advanced manufacturing, on material size, on material science, and these are mostly industries based out of Alberta. So in terms of advanced manufacturing, I'd like to highlight 4 key areas that we are working on, and I'll give some quick examples of some interesting project and the challenges that we are trying to solve. So we are living in an era where it's very fast. We can create new materials with all the 3D printing going on. People can build custom 3D printer very easily with industrial automation and industrial IoT system. So we, at our centers, have built our own 3D printers, which are very good in terms of creation of new material. Now, where lies the challenge? The challenge is to create a stable, repeatable, cost-effective material. So we can create a high-cost material, but no one will buy it because the economics doesn't work. So how do you do that so that you can adopt new material technology? So one of the industry who came to us, they are based in Alberta. So what they are doing is they are recycling plastic. So what is the challenge? The challenge is when you take a plastic product, it has multiple grades of plastic, which means it has multiple types of polymer. Now, when you shred that plastic and you want to make new plastic out of it, and when you 3D print it, there is no stable strength within the material. So how do you create new material and recycle it? That can be done through series of experiments that needs to be done in the 3D printing space, where you can create the new material. That is, you parameterize that based on viscosity, temperature, and a lot of other things, which I won't go in details. I'll keep it at a very high level. So that's where artificial intelligence comes in, because you can make a digital twin, and then you can kind of zoom in and reduce 10 years of experiment, maybe in 3 months. So once we do that, then we can create those new materials. The other area I'd like to quickly touch on is smart materials, as Andrew mentioned. So there is a company based in Alberta. They are manufacturing smart material, which goes on clothing. So, and these are all Alberta companies, by the way. So manufacturing of this smart material needs very precise application of computer vision and robotics. So that's where advanced manufacturing plays a role. We are also starting a project with Alberta Innovates sometime in May, where we are taking bitumen, and we are trying to make plastic products out of bitumen, which has a 3 times more market value than conventional use of bitumen. So we are we'll start that project sometime in May.
Thank you, Deb Jody. Stephanie, over to you. Could you provide us with Amy's perspective on the role of new materials?
For sure. So I think one of the most exciting things about being in AI is that AI really lives up to its potential when we get to collaborate with domain experts who have incredible insights and opportunity in their own fields. And I think with new materials, this is especially exciting. AI is also really greedy, and we're greedy for data. And so when it comes to new materials, I really see that as a new opportunity for massive data. And those data points allow us to really use AI as a tool to analyze opportunities for improvements related to things like structure, processes, and even performance. So as we think about new materials and advanced manufacturing, our role as AI experts is to really think about how is AI your partner for insights or interpretation of what's possible with all the data that you have. Part of that is also making sure that AI is really brought to fruition by thinking about in 2 sets of 3s. So when you're deploying an AI system, perhaps to discover a new material or to optimize a new manufacturing process, you really have to think of that system as doing 3 things. It's storing the data, it's processing the data, and then it's using it to leverage new insights. And sometimes in our land of reinforcement learning, really using experience to see new insights and learning. But for that to really be successful, the industry and the researchers need to think about 3 pillars to set AI up for success. And that's talent, so having really passionate people in industry and on research who understand how to communicate outside their domain. It's access to amazing data sets and really accurate data sets so we can get great predictions. And the last piece, which isn't to be ignored, is the infrastructure of compute that allows industry and researchers to actually power the AI for these insights. So I think it's all about collaboration and really thinking about what are those steps we need together to set both industry and research up for success so that we can find these advances on both sides.
Thank you. Collaboration is a key word within Alberta Innovates. That's what we're looking for throughout the tech ecosystems within Alberta. Next question, and I'm going to start with Deb Jody again, or start with Deb Jody here. Can you highlight the cutting-edge research currently being done at Red Deer Poly in material science and its real-world impact on manufacturing capabilities?
Absolutely. That's a great question. So one of the cutting-edge research that we are doing in material science is actually in collaboration with University of Alberta and with Andre's group. So the project started around 5 years ago, I think. So it's developing new composites which have a particular density, particular weight, and very high strength. And these composites are used for the aircraft industry. So a common question I get, why can't we make this using traditional manufacturing process? Why do we need to invest in cutting-edge machineries and so much on the technology to manufacture these materials? The answer to that is because traditional manufacturing is subtractive. Think about a square box, and you have perforated holes in all the wall, and you have a complex structure. Why do those structures exist? Because you get massive surface area compared to your weight, so you get more mass and heat transfer once you have more surface area. So how do you create the structure in traditional manufacturing, which is this small? So your tooling on go inside to create those perforation is not possible. That's when you do something called metal 3D printing using binder jet. So you build layer by layer on top and kind of glue the structure in a certain way to develop a structure. So we used a binder jet printer, which is a cutting-edge technology in metal 3D printing, and develop certain new materials and send it for testing at U of A with their scanning electron microscope. U of A has very nice toys, so do we. So we send it to them, and we got results. So we optimized what we are doing, and I'll pass it on to our next person. And when Andre talks about it, then we can talk more about what was the application of the project and where it gets applied, probably.
Over to Andre.
All right, so so I'll maybe add a few points onto that, and just to build, and also to build on some of the things that Stephanie has said. So before I start to answer that question, though, Stefan, we're hearing a lot from industry in Alberta, but then also industry internationally about what they actually want from researchers, especially in the manufacturing space. And one of the things that they're telling us that they want is increased efficiency and increased productivity of their processes. And the way how they want to do that is, of course, integrating artificial intelligence, but also integrating things like autonomy. And one of the things that the University of Alberta has been doing in collaboration with Red Deer Polytechnic, but also the Northern Alberta Institute of Technology, as well as the Southern Alberta Institute of Technology, is really looking at, and Innotech Alberta, I should add, looking at integrating into manufacturing processes things like autonomy, starting off with fixed robots that can actually deposit material without human intervention. So think about plasma transfer arc welding or wire arc additive manufacturing is something that is being done at Innotech right now, but in collaboration with the University of Alberta and with NATE. Now, let's think beyond that to a scenario where you want to get things fabricated and done in the field, but you do not want to have human intervention there because maybe it's very cold or the environment isn't safe for people to enter. So that's where things like the work of, say, Professor Ehsan Hashimi from the University of Alberta on mobile robotics is really building in a lot of those technologies where you're integrating things like visual, inertial, navigation systems, VR, for example, into the processes in order for workers to get the manufacturing done in the field where it's safe without actually, having intervention. Reinforcement learning is also built into that as well. So those are some of the things that are happening not only at the University of Alberta, but also across the province and in collaboration with international partners here in Germany. And we've seen a lot of those robotic, kind of devices around here at Hannover Messe, which is really, again, signaling the desire of industry to want us to actually produce these things in the province in Alberta. So that's just, my big take on it for that.
It's very interesting. Stephanie, could you give us Amy's perspective?
Sure. So research is really at the heart of what we do at AMY, and I think probably for international audiences, it might be surprising that Alberta, and through a predecessor of Alberta Innovates, actually started investing in fundamental AI research in Alberta in 2002, so long before what we see in our current kind of hype cycle of AI investments. And so those investments early on have allowed us to really establish this excellence in AI, most focused on fundamental research that led to wonderful awards like Dr. Rich Sutton's recent Turing announcement a few weeks ago. I think what's exciting for this kind of next generation of AI research is there's so much more science to be done, and we're really excited about expanding our research chairs, specifically at the intersection of domain plus AI. And so building up a generation of talent, specifically at the graduate level, that speaks two languages, that they are advancing research in domains like material discovery, engineering, biology, health, even neurology, but also advancing AI studies. And so I think this piece that's really key, bringing it into industry, but also research collaborations, is having new talent deeply excited about the application of these technologies and the beauty and joy of working with small and medium-sized enterprises, which are at the core of many economies. And I think we're making that transition. And so beyond the specifics of the research, I think it really comes down to relationships, connection, and passion, because often undergraduate students in CS or computing science have been hyper-focused on coding and CS. And the minute they get to talk to someone as passionate about their domain, they're like all in. And so our graduate students love going to manufacturing floors, they love going to farms, they love being in clinic with patients. And so I think that's one of the biggest opportunities for international collaboration, is really getting our talent to be really well connected. The part of research on AI that I'm most excited about is really this idea of reverse engineering or inverse research design. So using something like large language models or generative AI to help us discover new materials. So using all that data and then actually prompting a model to say, I need a material that does all these things, and maybe getting some creative or novel approaches that then you can test, rather than our traditional format of creating a material and then testing. And then personally, I think additive approach is really bio-inspired materials. And we're seeing a lot of interesting data sets available from our bio friends, and using that data inform this kind of predictive materials design.
Very interesting. And are you getting lots of interest here at Hannover Messe in Amy's capabilities?
Absolutely. And I think it's really around that opportunity for dialogue around expertise and finding those opportunities for connection. So many startup founders from the German ecosystem thrilled to connect, especially with reinforcement leaders at AMY.
Thank you. For our third question, I'll give you the opportunity to answer first. So if you could please discuss the practical challenges in implementing Industry 4.0 at scale and how research can address these hurdles.
So I guess I have the challenge, but maybe that research can address the hurdle. I think it's around industry investment. New materials are rich possibilities for data sets, but having industry commit to making that data available and accurate is a huge challenge, and without that data, it's really challenging to integrate the AI. And I think it's also the interoperability of the systems that we see across manufacturing sites. So how do we find opportunities for that kind of legacy system to start working with a new system? Because that transition, and we all know how hard change management is on the shop floor, on the manufacturing floor. I think the other challenge, especially with the AI adoption in this space, is a level of trust, but also explainability in the model, especially if we get into generative materials, is folks want to know how and why a model is recommending something, not to just take that recommendation blindly. And so mass literacy across industry leaders is going to be one way that we move towards that. So those are kind of the challenges facing, and I think on the research side, we're doing a lot in explainable AI outside of this specific domain that can be applied to advanced manufacturing and materials in the future.
Thank you. Andre, what's the perspective from the University of Alberta?
Absolutely. So, as another, perspective, on top of that, a couple of things that we are observing in the field, and maybe I'll start from the industry perspective and then just pivot over to the academic for a little bit. So, industry wants things like Industry 4.0. They want automation. They want to integrate AI. But when you look at heavy industry manufacturing, so the welding, the laser cladding, the thermal spraying folks, the first question they'll say, well, what really is AI? I don't get it. I have no clue. They need training. So to Stephanie's point, that's the first thing that they require. The workforce development is something that's very important, and it's actually going to create a barrier to the integration of a lot of the productivity technologies, or the technologies that will increase productivity in the marketplace. So that's something that's very important. From the research side of things, what we are seeing is that we need more tools in order to actually do the research. So I really liked what Stephanie said again about this kind of a priori approach to materials development, right? Developing it on the computer first before you actually get into the lab or on the shop floor and make the part to then test it through a number of very expensive testing methodologies, right? So that's something that is important. So, giving us, on the research side, things like artificial neural network tools that we can use to do iterative predictive modeling, right? Those are the kinds of things from a research perspective that we really need, to actually get into that Industry 4.0 stage, because at our level, we're looking at actually creating the materials, but making sure that they have the properties, making sure that they are ready for the performance that we want to put them in. And then we have to take that all back and say, oh, does the process really work? What should be the parameters of that laser cladding tool or that thermal spray, air plasma spray process that we're using, right? So there's this really iterative process that really goes in, and then having the appropriate tools to get that done is something that we actually really need for the work that we're doing on the research side. So our research question then is developing the tools that we're actually needing to use to develop and predict the material properties that we want in the end.
Thank you. Deb Jody, how do you see things from Red Deer College's perspective in terms of practical challenges in implementing Industry 4.0 at scale, and how research can address these hurdles?
Thank you for that question. We are building a new facility to host equipments, robotics, automation, injection molding, and thanks to Government of Alberta for all the support, CFI funding, and Red Deer Polytechnic to enable us to build that building. And it will be a very exciting journey for us in the Industry 4.0. So we did a market scan, sitting with all the industry leaders from small and medium-sized enterprise and large corporations to find out what are their challenges. And I used to be a robotics integrator, owning my own company in the past. So I also understand the challenges. So the major challenge is, why would a company invest and take such big risk when the investment goes more than $1 million when you invest in a robotics and automation system, when you don't know whether your bottleneck or the key process will work or not? And where would they go to de-risk this process? So that is a major challenge in the industry. So based on hearing the industry, what Red Deer Polytechnic did, Red Deer Polytechnic is setting up a flexible automation system. So there will be flexible stations where when we get a request from an industry, we can repurpose a robot from pick and place. We can make the robot to scan something within 3-4 days, and that can be enabled through digital twinning. So we can create a digital twin of what the company wants, and very quickly on our shop floor, we can change how the robotics will work. So what it does, it helps industry to come and try a new process. Let's take an example of one of the companies who is building some smart textile. So they doesn't know if they invest $250,000 on a robotic system, whether the key process of applying a certain glue will work in the textile, because no one has done that before. So we can de-risk that part of the process using our robotic system, computer vision system, artificial system, and show them that it works. So the robots have been around for 40, 50 years. And the industry is very matured. I don't see there will be much improvement in the robots itself. There will be more collaborative robots in the world, and the future is humans and machines working together in a safe environment. But the improvement will be integration of smart sensors and data and interoperability between systems. That's what Red Deer Polytechnic is trying to solve, so that industry in Alberta and Canada can produce faster products. And there are some great examples that we saw today morning right here in Hannover Messe, where it's quite inspiring to see those, and Red Deer Polytechnic is trying to partner with some of the key industries who are present here. Thank you.
Thank you very much, Deb Jody. I'd just like to pass it back to each one of you, just for a few closing comments on today's discussion. Does anybody volunteer to start? Andre.
I'll go ahead, I don't mind. So yeah, just a couple of I guess quick takeaways from a very high level. So Alberta has a lot of resources, and when I say resources, I don't just mean oil and gas, only. I'm talking about human resources, right? A lot of talent, a lot of ideas. And just based on the number of people who are here from the province, University of Alberta has 20 people plus here, mostly scientists and engineers, are here. The talent is here, and we want to engage with international partners on a lot of the work, that we're doing. So, what we are, looking at from a research perspective around manufacturing and additive manufacturing is really a platform around research, driven by industry, informed by industry, so that way we get solutions that can be deployed into industry operations sooner than later, but then also building a workforce development around that, specifically for additive manufacturing or advanced manufacturing. Because with that kind of platform, we'll actually be able to get a lot of really good outcomes very quickly, and actually have a more fulfilling experience working with colleagues and other companies that we have here at Hannover Messe, for example, or elsewhere across the globe. That, of course, is going to build not only the capacity of the province, but also the capacity of our partners internationally. So that's something that I definitely want to maybe take away, or give the audience to take away. And one of the ways, maybe I'm a little bit biased to this, but one of the best ways to do that, in my opinion, is through a research and development platform, because that's where the ideas are created, that's where the technologies are going to be developed for deployment, and that gives us the platform for actually training people and building that pipeline of next generation experts that are going to work in this field, especially in manufacturing and materials. Thanks, Stefan. Over to you.
Thank you, Andre. Deb Jody?
Sure. So Hannover Messe was a great conference to be in. And the reason I say that, because there are universities, polytechnic, industry is the biggest trade show in the whole world. So what I am gaining, I am trying to see what is the state of innovation in the whole world. And this is a platform where any one of us can see that. So instead of reinventing the wheel, if we can collaborate with someone who has already done something, then we can innovate faster. So one of the things I'm taking away is collaborate from Hannover Messe. The next thing I would like to do in SimTag is focus more on app-led side of the research where industry can come and they can fail fast so that they can move on with another idea or go to the next product. That's why we can foster innovation quickly, both in material science and in data science or whatever subject we pick. And the last thing I would talk about is the courage to innovate. So that's very important. Many companies we are seeing in Alberta, and the landscape has changed in last 10 years, that there are so many companies working on cutting-edge technology in the Alberta region. So the principle of courage to innovate is right now quite ripe in Alberta. And we as Red Deer Polytechnic, we are ready to help these companies. Thank you.
Thank you, Deb Jody. And the final word to Stephanie and Amy.
Well, I think one of the things that's really interesting for us at Amy is that with all of the new discoveries and applications of AI, kind of every industry and every opportunity like Hannover Messe is now an AI trade show, an AI conference, and we feel a great responsibility with that. And so I would say the first on the collaboration front is your AI colleagues are as curious about your domains as maybe you are about AI, and so please find us and share the things that you're most passionate about, because I think exchange on that passion is really powerful. And then the other piece, because it is hard when AI becomes part of everything, and maybe you haven't been exposed to it or have a lot of opportunities to interact with it, is at Amy we really take an approach of like rising tide lifts all ships, and our goal is to have impact, and we see all of the graduate students. So at Amy we have about 51 principal investigators and 500 graduate students. They're the most hungry to have impact, and they want to know what impact is meaningful, and so we're all driving towards that big goal of impact. And I think right now productivity is a big challenge within Canada, but also globally, and so that kind of shared pathway on productivity within this industry is something we could do together.
Thank you very much, Stephanie. And with that, that brings our panel to a close. But once again, I'd like to thank our three panelists, Stephanie Enders from the Alberta Machine Intelligence Institute, Andre MacDonald from the University of Alberta, and Deb Jody Sten from Red Deer Polytechnic. Please give us a round of applause. If anyone has any questions, please, you can join the panelists over here and speak to them directly. Thank you very much.
When we look at Saskatchewan, I mean, we are a major pulse producer. We've got all the elements of success for plant-based protein and plant-based crop value adding.
Saskatchewan is an innovation ecosystem that doesn't exist anywhere else in the world.
This is going to become a plant-based crop processing center of excellence for the world.
Mining is going to play a central and pivotal role in fighting climate change. We hope to establish a force to put Saskatchewan on the map as really being the birthplace of this revolution in the mining industry.
We're interested in stable fiscal regimes with strong resource potential and a strong and skilled workforce. And that's what we've got in Saskatchewan.
Willkommen. The next presentation will be about the Prairie's Innovation System, and I'll invite Jeff Cooper, who's the VP Trade Development of the Saskatchewan Trade and Export Partnership, to come on stage, please.
Thank you very much. Welcome everybody here today to our panel discussion on the Prairie Innovation Ecosystem.
I'm Jeff Cooper, the Vice President of Trade Development at Saskatchewan Trade and Export Partnership. STEP, we're the trade promotion agency for the province of Saskatchewan, funded by our provincial government to provide services to Saskatchewan companies looking to develop international business opportunities. Before we get to the panel, though, we have a very special guest speaker. There's no stronger voice for Saskatchewan interests around the world. Please join me in welcoming the Honourable Scott Moe, Premier of Saskatchewan. Sorry.
Thank you very much, Jeff, and welcome everyone. And thank you for not only being here, but thank you for what you do in advancing the interests that we have, not only in Saskatchewan and Manitoba, which is what we will discuss here in a few moments, but advancing the interests of Canada and advancing and collaborating around the world, which is really what this show is about. And it's a really, truly an honor for myself to be here as a Canadian to co-host the show here in Germany. Alongside Francois Legault was here yesterday, as well as the minister from Edmonton, or from Alberta, pardon me, as well as the minister from Vic Fideli from Ontario. So it brings me a great honor to introduce our panel here today. In addition to our moderator, Jeff Cooper, who runs our Saskatchewan Trade and Export Partnership, we have an esteemed panel with starting with Vikram Banthia. He's the director of the Price Institute of Advanced Manufacturing and Mechatronics at the Red River College Polytech. We have with us as well Dr. Hans Joachim Wieden. He is the Associate Vice President of Partnership, Knowledge, Mobilization, and Innovation at the University of Manitoba. And from my alma mater, we have Dr. Baljit Singh. He's the Vice President of Research at the University of Saskatchewan. And Haz Malik is the Provost and Vice President at Saskatchewan Polytechnic. That is going to be our panel today. And they are going to discuss, I think, a couple of things. One is, how do we innovate? And then two, how do we collaborate between Saskatchewan and Manitoba? And I think you can take that collaboration far beyond just those two prairie provinces. And what we do in the prairie provinces is we create the opportunity to provide the world with food, fuel, and fertilizer. And as you saw in the video, there are great fields of agriculture, and some of the most sustainable and innovative agricultural production in the world is happening in these two provinces. It's happening, and it is the most sustainable in the world, much due to the research and innovation that is happening at these institutes and by these individuals that are going to be up here today. The mining sector is most important in Manitoba and in Saskatchewan, as well, as we are producing not only the uranium and potash in our province, but many of the critical minerals that are necessary for how we are going to power our future are coming right from these two provinces here today. So if I could, and if you would, alongside me, welcome our esteemed panel coming up here today to discuss how we are going to power our future, how we are going to feed those in our future, and how we are going to ensure that we have a bright future ahead of us, thanks in part due to Saskatchewan and Manitoba resources, of which the most valuable resource is the people, and here's four of the great ones right here. Thank you very much.
Yeah, absolutely. Thank you. Are we on? Oh, there we go. Okay, thank you, Mr. Premier. We really appreciate you being involved in this event. And thank you to our panel for taking the time to be involved with us and speak today. I'm excited to hear what you all have to say. Obviously, STEP is one piece of the prairie puzzle. This event is supported by the provincial governments of Saskatchewan and Manitoba, specifically our Ministry of Trade and Export Development and Saskatchewan's office in Germany, and Manitoba's Ministry of Business, Mining, Trade, and Job Creation, which is definitely a mouthful, but you know, we're working on that. We have several colleagues from each department here in the audience. I won't take time to introduce everybody, but just know that this event would not be possible without everybody here. I would also like to thank our partners at ISET, NGen, and Global Affairs Canada. It truly is a Team Canada event here at Hannover Messe. I'm excited to get to moderate this panel today. Saskatchewan and Manitoba have a long history of working together at international events. In my time at STEP, there's been numerous instances of collaboration between our provinces. Often working together, we can generate a larger critical mass at these international events and have more of an impact. Today's event is no exception. You'll hear from members from our academic community on the exciting innovations happening in our provinces. Both provinces have a long history of developing innovations that have started at these institutes. From cutting-edge crop science, sustainable farming technologies, life-saving medical advancements, and renewable energy solutions. And from STEP's perspective, we've been able to help take these innovations and export them all over the world. And it's at events like these that allow us to showcase what our provinces have to offer. And given the current climate of global trade uncertainty, finding new partners and new markets is as important as ever. With that today, let's get on to the panel discussion. So I'd like to take a couple minutes, get everybody to sort of briefly introduce themselves and their institute. Dr. Vikram, we will start with you.
Hello, can you hear me? Yeah. All right, so my name is Vikram Banthia, and I'm the director of the Price Institute of Advanced Manufacturing and Mechatronics at Red River College Polytech in Winnipeg, Manitoba. So at the Institute, we offer academic programming. So we have 2 postgraduate diploma programs, and we also have a leg in applied research. So we collaborate with industries on working on real-life problems.
Great. Dr. Singh?
Thank you very much, Jeff. My name is Baljit Singh. I'm at University of Saskatchewan, which is a 120-year-old institution of higher learning and research and community engagement. We are located in Saskatoon, and that's where I oversee the research and innovation ecosystem that University of Saskatchewan plays a major role not only in Saskatoon, but also across the province and also internationally now. So very happy to be here, Jeff. Thank you very much.
Thank you. Dr. Malik?
Good morning, everyone. Good afternoon, everyone. So happy to see all of you here joining us in this conversation. I'm Haas Malik. I'm the Provost and Vice President Academic at Saskatchewan Polytechnic. The Polytechnic has around 20,000 students and around 200, a little bit over 200 programs. Aligned to all the economic sectors within Saskatchewan. So really is an economic driver for the province. And I oversee all the programming that's in the institution along with applied research and also international partnerships and global engagement. So looking forward to the conversation today with my colleagues. Thank you.
Thank you, Dr. Malik. And Dr. Whedon?
Yeah, thank you, Jeff. My name is Hans-Joachim Wieden. I'm the Associate Vice President, Partnerships, Knowledge Mobilization, and Innovation at the University of Manitoba. This is a long title, and I rather would have had it called like Associate Vice President Impact. I think that would be the way I would like to go for this. The University of Manitoba is, I think, the oldest university in the prairies. So that puts it into the historical context. It started as an agricultural college, which is related to the history of the province, I would say. The university has about 35,000 students. It's the largest university in the province and contributes about 10% to the GDP of the province. It is a very unique environment because I would say 90% of the population of Manitoba lives within Winnipeg, where the University of Manitoba is located, together with with a whole set of different post-secondary institutions. So it creates a very unique and dense innovation environment. And my role in my office as AVP Impact is basically to make sure that the innovations that are generated within our system actually are also deployed into the communities. And we have a long-standing history with the Saskatchewan institution, in particular with the University of Saskatchewan, to do these kind of training programs that allow the deliverable. So an example, for instance, what we're doing is, and I will be short, we just got awarded together with the University of Saskatchewan and other institutions some sort of training program coming out of ISET's and Lab to Market funding program, which ties the different provinces together in building a Team Canada approach of training the next generation of people. So that brings me to one of the projects that I'm leading, and that is Idea Start, which is making exactly that, bringing the ideas and the people together to solve our day's problems today, hence the impacting. Thanks.
Perfect. Thank you, Dr. Whedon. So we'll start, Dr. Singh, I'll start with you. How would you describe the current state of the innovation ecosystem in Saskatchewan and Manitoba?
Thank you very much, Jeff. When we look at any innovation system, we are talking about a system, there are some key ingredients that have to be in place. When you look at the German innovation ecosystem, which is one of the highly enriched and mature and impactful ecosystem in the world, you are looking at a very strong policy framework. The policy framework that comes from the government within which the institutions, whether public sector or private, are going to operate. Then the institutions need resourcing in a way where they can hire the right kind of people, build infrastructure, and use the infrastructure to focus on the type of things that a society needs at any given time. Lastly, there has to be very deliberate strategy on the part of the universities, I'm speaking on behalf of a university, to align themselves with what the people in a province or a region are needing at any given time. Now, let me take an example. When the University of Saskatchewan was created in 1907, it set up a goal for itself to be among the best in the world. But that goal did not come out of the blue, because Saskatchewan as a province in 1905 set up a goal to be one of the most dominant, productive member of the Canadian Confederation. So they are both aligned there. Province was developing agriculture, so the University of Saskatchewan began to focus on agronomy, training of students in the area of agriculture, training of women in the area of home economics, and that began to fuel the agriculture ecosystem in the province. No wonder that 100 years later, in the last 50 years, University of Saskatchewan has delivered 500 new crop varieties. That's one crop variety every month. You cannot do that unless there's a pipeline of basic science, right kind of infrastructure, and working with the provincial, federal, and the private sector entities. Now, where we sit, we have a very deliberate role to play in not only Saskatchewan, but in Canada's innovation ecosystem alongside Manitoba. University of Saskatchewan has built Canada's only synchrotron, where you can study materials, electric batteries, pharmaceuticals, and then it has Canada's soon only level 4 biocontainment facility where you could study Ebola virus, for example. That is part of Canada's pandemic strategy, and within that is a manufacturing facility where private sector entities can come and manufacture hundreds and thousands of doses of a vaccine to run clinical trial. So you are working up to create a management of the infectious disease and development of the agriculture, development of advanced materials, and finally, as the province really takes a major role globally when it comes to minerals and energy and the nuclear energy and the buildup of the small modular nuclear reactor, University of Saskatchewan, in partnership with Saskatchewan Polytechnic, University of Manitoba, RRC, has a major role to play in driving this forward through education, research, and mobilizing knowledge to the private sector. The last point I make is, which my colleague Dr. Malk will talk about very likely, is the cooperation between Saskatchewan Polytechnic and University of Saskatchewan right next to a major innovation park. This is a very interesting ecosystem which is prevalent in a growing province where population is growing and the small businesses are growing, and it's a very large export enterprise from the province. Jeff, so I will stop here. Thank you very much.
Yeah, perfect. No, thank you. That was a great answer. We'll switch gears a little bit. Dr. Banthia, one of the themes of this year's Hannover Messe is AI applications in advanced manufacturing. Does the research at your institute reflect the growing importance of AI usage in the modern economy? And could you talk a little bit maybe about a specific project and how it would affect modern manufacturing?
Yeah, for sure. This is a very timely question because we hear about AI every time. So the research that we do at our college and at the Institute of Advanced Manufacturing and Mechatronics, so we have full-time researchers, again, expertise in AI. So they have PhDs and masters in artificial intelligence and machine learning. So they are dedicated full-time to help industry to innovate, bring in more automation, bring in more AI into their plants. So traditionally, we have been working mostly on agriculture, right? So both the provinces are heavily on agriculture, but our institute wants to promote more of manufacturing, so advanced manufacturing. So that's where the AI is more prevalent. So let me give you a couple of examples that we have worked with the local manufacturing companies there. So there was a local aerospace manufacturing company. So they came up with a problem to us. They said, we want to do a quality control. So we want to detect some defects in our parts. So what can we do? So traditionally, machine vision is very expensive. It's rigid, and it's very hard to program. So we came up with a very low-cost solution. So this is called Trainable Automatic Vision Systems, a TAVS. So this is based on Raspberry Pi. So we have a computer vision system, a Raspberry Pi, anything that you can find very cheap, so it's not even more than $200. So we came up with AI-driven model. So we fed the system with 1,000 of images of the part that it was trying to detect. And based on that learning model, they were able to reduce the time it takes for you to detect a defect or a misalignment by close to 50%. Right? That was one of the examples. The second example is the preventive maintenance. So again, artificial intelligence and machine learning is very prevalent when it comes to maintenance. So we can read the data from all the sensors connected on the machine. And based on the data, we can predict at what point the component is going to fail. So based on that, you can prevent machines breaking down as well, right? So those are some of the areas that we have seen AI being used heavily. Yeah.
Oh, thank you. Dr. Malik, in Canada, there are a lot of talk about the so-called innovation gap, referring to low R&D spending by private companies compared to other advanced economies. What do you think are the main reasons for this, and how can institutions of higher education help companies do more and better research?
Yeah, it's a really somewhat of a complex question and not an easy solution to it. I think we need to step back a little bit and think about the ecosystem that we are in terms of the number of companies that we have in Canada and what size they have. So if you look at it, over 90% of companies within Canada are small to medium-sized enterprises. And we define that by having a company having 500 employees or less. So if you look at that as a ecosystem as a whole across Canada, the challenge really arises as to whether those companies can have in their own shops R&D capacity, because there's a high risk and a high cost to that. But there's a second piece to this, because if you don't do the R&D appropriately, you won't have the technological advances to be in the marketplace and provide the value proposition that is needed to scale up. So the challenge that we have is that how do we scale up our businesses to the place where it can be a national or international enterprises? So that's a challenge. So what happens with institutions like all of us here who are representing the institutions of higher education, we have an opportunity to partner with those companies that cannot do the research on their own. So we can bring expertise, we can bring the resources in terms of our faculty, students. Also, we can leverage some of the opportunities that we have with the federal grants. So, if a company is putting X number of dollars, we can multiply it by 4 to 5 times with federal dollars that are available to NSERC and other grant opportunities. We also have a really rich suite of equipment and facilities that we can take advantage of, and in partnership with companies. One of the unique propositions that I know the Red River College Polytechnic also has, and Saskatchewan Polytechnic has, we don't keep any of the IP. So there isn't any risk to the companies who are coming to work with us, because we'll provide the expertise to solve their innovation challenge, and then they get the opportunity to keep the IP and take advantage of that. So I think that's a really good ecosystem that we have built. The challenge for us is that there are a lot more demand than we have funding for. And so the question really is, going back to my friend Dr. Baljit mentioned the fact around policy framework. We need to look at the policy framework. If we're serious about advancing innovation within Canada, we need to look at policy framework for how do we make that happen, and how do we create capacity within institutions to support the work that small and medium enterprises need to do.
Thank you, Dr. Malik. Dr. Whedon, we're going to switch gears a little bit here. Not everyone in the audience might be aware, but reconciliation with First Nations people of Canada is an ongoing topic of discussion, particularly in Saskatchewan and Manitoba, as we have very large First Nations populations. Do you think innovation can play a role in helping with this reconciliation process?
Yeah, thank you, Jeff, for that question. And I'm happy to have the opportunity to answer and to speak to this, because this is an interesting challenge from a Canadian and for a provincial point of view, how to form our country. And when you say we have a large population of indigenous identifying people in our communities, that is true. In I don't know exactly for Saskatchewan, but in Manitoba numbers will be similar. In Manitoba, it's about 18% of the population is indigenously self-identifying. So which means, and it's the largest growing fraction of population in the province. And so the question is, can we innovate without this part of our population partaking in that? And so innovation is a great way of giving ownership to the society and to the country of anybody in a population. So providing a framework that allows indigenous communities to partake in the innovation process is absolutely critical for us. And I'll just give you an example of how that is. It is a nation-forming piece because, as I said earlier, 90% of our population is located in Winnipeg, and then there's a lot of land, and there's a lot of borders, and there's a lot of north. And when you look at and I often say that, like Manitoba is actually a maritime province when you think of it, right? It is, with the Port of Churchill at the Hudson's Bay, we actually are a maritime province. And the Port of Churchill is indigenous owned. So which I think is a great way of focusing on that coast in an indigenous innovation space. So all of what happens within the in discovering the water flows within the in the lands and the energy that is produced in Manitoba is happening on indigenously owned lands, right? So understanding how the water and the land develops is a critical part of the innovation process around, at least in our province in Saskatchewan, will be exactly the same. So building frameworks that allow the participation not only will contribute to reconciliation within the country, but it will also allow to benefit, or not benefit is the wrong word already, it's already an extractionist approach to this, but do a holistic approach about how we as a province, as a country, build and benefit again, have the opportunity of measuring impact of what we do. And the major piece that we often see in the type of innovation that comes out of indigenous enterprises is community-based. And that brings me back to the point of the distribution within the provinces. A lot of solution and innovations occur in the communities where the problem arises. So fostering a distributed innovation ecosystem that helps indigenous communities to drive and own the innovation piece is exactly what we need to do and what will shape the future that we have.
Oh, thank you. Great answer. Any further comments on that? Anyone else want to jump in on that? Yeah.
Yeah, just one piece, and I think you touched on a really important piece, which is there's a cultural reconciliation and there's an economic reconciliation. Right. And the innovation framework that we are talking about is really how do we empower the indigenous communities to have their own economic vibrancy, right? And you see that shift happening across Canada in the indigenous First Nations. They are really interested in sustainable solutions. Yeah. They want to be a partner and a voice in the kind of really large challenges that the nation is, and I would say globally we're facing, whether it's around climate change or even nuclear energy. It's their land that we are using. And I think that partnership is a really good thing. It's going to benefit them, but that's going to benefit us as well. So, and we are one nation, and we need to look at that from that perspective.
Anybody else want to touch on that?
Yeah, actually, there was a great point about the percentage, right, of population. So if you see 18% of the population not being involved in the ecosystem, you cannot win, right? So I think it's really important for all of us to be involved in innovating and in creating innovative solutions for our industry, right? So the 18% is a very, very huge amount, yeah.
I mean, we have seen globally in so many post-colonial countries, the path to success and development is through education. At University of Saskatchewan, 20 years ago, only about 5 to 6% of the student body was comprised of those coming from First Nation and the Métis Nation of Saskatchewan or Inuit peoples. Today, that number is about 16%, very much close to the demographics that we have in the province. That did not happen without effort. It was an engagement with the communities. It was an engagement with the high school systems. It was creating the right kind of environment within the university so that the First Nations, Métis, and the Inuit students feel at home, creating a student center for them, having a series of researchers engaged in history, health, policy, engineering work with the First Nations communities. Last point, 4 years ago, we invested 3 Canada Research Chairs, which is a federally funded professorship program in Canada, to work with the indigenous communities from engineering to languages to archaeology and to the health. So we need to really have all these steps in place. As I said early on, right kind of policy framework. We are in a province where government is providing stability to us through predictable funding from year to year, predictable research funding through Agriculture and Innovation Saskatchewan, and the alignment with the trade work which is done in Germany and London and other places. They keep on highlighting the value proposition of the universities, Polytechnic and University of Regina, within the ecosystem of the province. So you see the pieces in Saskatchewan are coming together. They are reasonably well aligned. I think we hope to do better in the coming years so that Saskatchewan continues to advance. It is economic enterprise for a sustainable prosperity for people of Saskatchewan. That's the mission of the university at the end of the day, to create a prosperous, sustainable way of life for communities locally and globally. So I think that's a bit of a broader answer, Jeff, and that's where we sit.
Yeah. Actually, there's one more point I'll quickly add. So at our college, at Red River College, so our VP of research has also the portfolio of indigenous studies, right? So that was strategically done to have research and involving all the indigenous populations as well, right? So that was a great move from our college. Yeah.
Perfect. No, thank you. So lots of great work started, more work to be done, basically, on that topic. We'll talk a little bit. Obviously, we are in Europe or in Germany. Talk a little bit about our relationship with the EU. So, question for the group. So, feel free to jump in. There's already a lot of R&D cooperation between Canada and Germany, as well as other European countries. And there's the 10 billion euro Horizon Europe Fund set up by the EU, which also includes Canadian institutes. Where do you see the biggest opportunities for your institution for cross-Atlantic cooperation, and where could we do more?
Maybe I can start quickly. So at least at our college, we have an expertise when it comes to AI, right? So artificial intelligence and advanced manufacturing. We work a lot on sustainability as well, like so clean technology. So there are tons of examples I can think of. So one of the examples that we worked is with New Flyer Industries. So New Flyer Industries, Manitoba Hydro, Mitsubishi Heavy Industries, and our college. So we collaborated to come up with the first electric bus in Manitoba, right? So that was one of the things that we are really proud of. We also work with another local manufacturing company. So they make batteries. So that was used in Tundra buggy. So that's used in ecotourism in Churchill. So they were using diesel-powered engines before. So we converted it into all electric. Right, so sustainability is something we feel proud about. Like we have done a lot of things in that. AI is an upcoming stream, as I said. We have experts and we have professionals in the AI field. Again, so those are the two fields I feel that we can contribute a lot and have more collaboration with Germany. Yeah.
I mean, to talk about the systems alignment. So Horizon is a good example where Canada took associate membership about a year and a half ago. The U15 universities, there's a group of universities in the country which are most research intensive. There are some over there. My colleague from University of Manitoba, we are part of that. We have been engaging with a group of top 15 research intensive universities in Germany to develop the academic collaboration between the two groups. We had a gathering here in Hannover about 10 weeks ago, 9 weeks ago, to really continue that work between the universities in the two countries. To bring it down to the local level, University of Saskatchewan, 4 years ago, we began the process to decide on the countries where the university will be spending lots of effort to develop collaboration. So what were the principles? provincial trade export strategy was one of the major driving factors. Where is province of Saskatchewan engaging for trade, for immigration, and for a variety of other reasons? Saskatchewan has opened 9 trade offices in London, in Berlin, in Singapore, in New Delhi, and so forth. So we picked up the countries where Saskatchewan is actively playing a role. Bring it down one step further. In the last 2 years, we have made huge inroads into Germany through very well-funded programs. This week at Goethe University in Frankfurt, we launched a $1.7 million training program in environmental toxicology between the 2 universities. As you know, whenever we do mining, we need to look at the environmental issues. So it's very much aligned with what we do. We signed up an agreement with the second oldest veterinary school in the world here in Hannover. We did that on Sunday. The student exchanges will begin very soon. We have an agreement with German Academic Exchange Service. We are going to be doing student mobility with them. So really thinking about the systems level approach, but at the end of the day, it is the individual entities as to what do they deliver as part of their strategy, as part of their resource allocation, and as a part of the understanding what we do. Last point I will make is, in Canada, the challenge for us is, like Germany's student mobility program has 1.6 billion euros in it. In Canada, we don't have anything like that. Germans will invest 4% of the GDP in their research innovation system. I was member of the Bouchard panel 2 years ago recommending to Canadian government to scale up investment into our research innovation system to cover the type of gaps that Dr. Malik has outlined. There is some movement in the previous budget where government increased funding for research, but we still have a bit of the way to go if we are going to play in the fast-moving innovation ecosystems of the world, that is South Korea, Israel, India, Norway, and here in Germany. So I think we really need to organize ourselves in a systems-based approach so that we can deliver for Saskatchewanians, for Manitobans, and for Canadians overall through knowledge mobilization. So thank you.
Yeah, I'll pick up where Baljit left off. I think that's an important point because really it's like, do we see education, especially post-secondary education, as an expense or as an investment, right? And if you look at it from as a perspective of investment, then you're going to see ROIs, right? And then the investment policy comes in place. And I think we can't underestimate the policy framework that a nation has in terms of making an impact in this kind of an environment. Coming back to the opportunity from with Horizon Europe, from Saskatchewan Polytechnic, very much like RRC, the AI, machine learning is definitely an opportunity. Forestry is another space that Saskatchewan really thrives in. We have a lot of expertise in that area. I see a lot of opportunities for us to partner with German institutions for research and training opportunities there. Agriculture and mining, again, another areas that we excel in. We are currently having a number of conversations with potential partners in launching a grant application. So we'll see where that goes because it's an involved process and we're hoping for some success in that area.
Yeah, I want to make 2 different points. I'm going to start with the EU answer, I guess. So the Horizon program is a great thing. And we were really impressed by the fact that when the agreement was signed, we were ready to deliver joint applications at the get-go. We received funding over $100 million right in the first year, basically on established collaborations that already existed between researchers at the University of Manitoba and researchers in Germany, for instance, in that case, in the space of synthetic biology and biological engineering, right? That is great, and it shows how natural that joining of the different funding agencies is. Or funding envelopes is. What I also would like to stress is Canada has a land border with Europe on the Hans Island, which I always refer to. It's the name of, that's a good thing. So we are basically part of the EU, if you want to look at that. But fundamentally, it is actually showing that that's ready. So other pieces, and I echo what Baljit has said about like the areas of focus, but other areas where the University of Manitoba is strong is, for instance, in medicine. Like one of the best performing patents that the University of Manitoba has is the respiratory system analyst piece, all technology about analyzing the respiratory system and support structures. So there's a lot of innovation that happens in that space that naturally can be translated into the European market and into the European research environment. The other piece that we have is public health, for instance, right? We have a strong foothold or a strong footprint within the African continent in delivering public health, and that infrastructure is there. So all that kind of remote telehealth is a stronghold that University of Manitoba is partaking, but Canada in general is partaking that because of that, of the vast land that we are trying to service in, right? So that is something where the European connection between technologies and innovation are natural. So I think, yes, there's great potential. We just have to seize it, and I think everything is nicely connected. We just have to go and move on it. But on terms of that point about you can see university education as an investment or a cost, I 100% agree with that, and I would actually like to take it a little bit further than that. Because we often think of universities as deliverers of degrees, and that's what they do. But actually we are past that. We are training a workforce, but what we should be doing as a public funded institution is think about of the student, which is our customer, and think about the customer journey that goes through this. But ultimately why would a student come to a university? 10 years ago, myself included, I would want to get my degree, my PhD. But actually a student needs to have a life after leaving the university. Given the fact that the university degree's half-life time is probably like 3 years, we need to think differently about this now. And what we're doing is the university enables career development. You go to the university, obtain a post-secondary education to build your life afterwards. So which means building connections internationally, having outlets of that knowledge, mobilization, and actually building the receptor capacity for the degrees and having people stay in the province to capitalize on the investment that you had in the education is the key where we need to go. And thinking of that as a career development piece. Somebody needs to get up and say, I want to take my degree at the University of Manitoba because then I know I'm going to have a life afterwards that is good. And that, I think that's how times have changed, how we think about this, right? And it can be the University of Saskatchewan as well, for that matter.
We're not biased at all, yeah. Switching gears a little bit, maybe a boring topic, but government policy. What can the governments of Saskatchewan and Manitoba do to support more commercialization of research? Like, what is there any change in policy that might be possible to improve that?
I can maybe get that quickly, and then while you figure the microphone. So I think one of the pieces that we see, which is a challenge in commercialization strategy, is actually that I'll speak for that from the University of Manitoba point of view, is access to CEOs that drive things. And receptor capacity, right? And so I'm on the panel on the Canadian Council for Academies innovation panel, and one of the general themes that we identify is that we can innovate whatever we want. If we cannot take it up at some space, it will be lost. And it historically will be lost usually to south of us, in terms of, because there is funding to this and there might be a CEO and the smaller companies that can take this up. Canada has historically built their receptor capacity on large companies, like Research in Motion, for instance, was one of classic examples for that. But when you look at the European countries, they have a different type of receptor capacity in terms of innovation. They have large companies, but there's also a lot of mid-sized companies that do R&D and that actually can take ideas up and now the other one is market access, right? They can actually sell it. And that's one of the challenges that we see, is receptor capacity and market access is one of the key pieces there.
Yeah, maybe I'll add a couple of things. So, I think there are certain programs. I think the lack of awareness when it comes to industries, right? They don't understand how to leverage those incentives. For example, there is a program called STRED, right? So scientific research and experimental development, right? Yeah. So they provide tax incentives that, again, many companies in Manitoba were not even aware of that. So we also launched a new program which is called Lab to Market, right? That was mentioned. So our college is leading that initiative. But again, we need to create awareness of those programs to all the local companies that they can leverage our expertise. They can come up with innovative ideas, and then we can help them to commercialize it as well, right? So I feel there are certain programs, but obviously we want more from the government. But we do have certain programs that I don't think it is being used fully still.
You know, I'm going to maybe take a slightly different approach. I think the ecosystem itself is quite rich. When you look at Saskatchewan, we've got a co-labs, we've got a cultivator down in Regina. The ecosystem, you know, Baljit talked about the fact that we've got in Innovation Place a number of startup companies that are there. So I think the systems is there, the process is there. I think in some ways we've got a little bit of a protectionism that's happening, and I think the competitive spirit needs to come in. And I talked a little bit about scaling up. How do you scale up? And I think the market access is a really important point. You need to be able to take your products and market it. And so, like, how do we do that? What are the mechanisms? And I think the education of creating some opportunities for those who are struggling to scale up and giving them some training in that space. Maybe bringing some mentorship of companies that have been successful in scaling up and providing that mentorship. Maybe there needs to be a program around that. We've got entrepreneurship programs, but usually they're very successful in startup and accelerators, right, incubation. But it's not really about after that. Once you've got your product in market and you've got stabilized and you've, you know, in an SME, how do you take it to the next level? I think there's a real challenge. We haven't figured out that particular solution to that particular challenge.
I think that's I want to make a couple of points, but before I do that, I'm going to do, Jeff, with your permission, the director of our innovation mobilization, Alex Hayden, is here. She established a brand new incubator.
Putting you on the spot.
I wonder if you could speak for a moment, Alex, as to how you are doing, how the ecosystem is helping with that. Yeah. Ideally, you should have been on the panel, not me.
Thanks, Baljit. This is how we do things in Saskatchewan, so thanks for that prompt. So yeah, at University of Saskatchewan, we're in our third year, we established a deep tech incubator we call Opus. And what we did is we looked at our innovation ecosystem in Saskatchewan and said we have collabs, we have cultivator, we have technology-based incubators, accelerators. But what is the university contributing to that? We have to contribute new innovation. We have to drive those new ideas. I might not give him back the mic. And mobilize those out and play an active role there. And when we're working on it from within a university, then we need to have specialized programming with mentors, with networks who understand academic founders, and helping academic founders to contribute to the innovation ecosystem, because they're not always the same kind of founders that you see at coming to other accelerators. So yeah, it's part of our ecosystem.
Thank you, Alex. Thank you.
I will just make one point. Going back to the policy framework, I think, thank you, Alex. I think our premier is gone. It was 2 years ago, I brought up the idea, request to the premier that we need a provincial research innovation strategy. And so premier said, why don't we meet? So we met along with the Minister of Innovation, Trade, Export, Mr. Harrison, Minister of Advanced Education, Deputy Minister Jody Banks. We met for an hour and a half to understand that piece. And now we are working with Innovation Saskatchewan to develop a provincial research innovation strategy that will guide provincial investments and the role that Saskatchewan Polytechnic, University of Regina, and USask play in delivering knowledge and the products to the Saskatchewanians. One piece which ecosystem always needs, there is a red-hot competition for global talent. In Canada, we need to figure that piece out. One of the ideas which we are working with the provincial government is to create top-level graduate scholarships where you can bring the best from India to China to Germany, from Timbuktu, wherever they are, to play a role in Saskatchewan's ecosystem. I think we are working closely with the province. They are always open to ideas. So we need to be engaging with the policymakers, with the private sector to close these gaps. Quite a bit of the burden lies on the universities to step out and offer infrastructure to the entrepreneurs. I think University of Saskatchewan has maybe at least $1 billion of infrastructure. Even if you were to mobilize 10% of that for private sector, you are looking at $100 million of infrastructure. I think you can do wonders. Thank you, Alex, for your comments.
Thank you. Dr. Reed, jump in.
If I can please follow up on that, that is true. I mean, this integration of providing resources to the upcoming companies that allow the scaling is a piece where even if you have market access and you cannot produce your prototype, you don't have. But that we have under control. But one of the major challenges as well is having access and knowledge about these opportunities. So we at the University of Manitoba are starting a program that's called Idea Start, as I pointed earlier out. And what that fundamentally is, it is a meta search engine about all the existing pieces in the ecosystem. Because the innovators that come to the province and want to build or deploy something, they don't know whom to ask and how to navigate this, right? That is a critical piece that we identified that accelerates that process, and that includes the whole ecosystem, right? And an example for that is the joint thing between the University of Saskatchewan and in the accelerated biotech, where we can move between the Vido lab and our lab in terms of deploying and scaling something. But also access to lawyers, access to funding, access to these opportunities is a barrier. So if you have an easy entry point into the system, like the internet, where you just Google when you need an information, right? We need to Google for the innovation ecosystem, where you have a trusted source that gives you credible referral to a certain piece. And I think that's what we're building, and that's a missing piece that actually then jives nicely with the existing infrastructure that we have.
Absolutely. No, thank you very much. I'll put a small plug in for STEP and for Sharon's department at the Government of Manitoba. We do a little piece there. Once those companies are kind of at that stage where they're commercialized and they're looking for new markets, that's where STEP, that's where the Government of Manitoba jumps in to help find those, to bring companies to events like that. So it's all playing our little role in that ecosystem. I know we're getting close to time here, so I'll quickly, one last question. Would you like to share a success story from something that started as an idea at one of your institutes that's been commercialized and is maybe a major advancement, something like that?
Let me give you really an example which is truly phenomenal. In 98-99, a couple of professors at University of Saskatchewan discovered a new virus in the pigs. It was a simple discovery. They saw a new virus, they reported it. Few years later, they found out that this virus is associated with a particular disease in the pigs. Then it became clear that we need to not only make a diagnostic test for that disease, but we also have to make a vaccine for that. One of the large pharmaceutical companies picked up the product, they made the vaccine, and I found out from them a few months ago that that is the most successful animal vaccine ever made. To put it in scale, it has brought $100 million of royalties to University of Saskatchewan. So if that story really sends a tingle up your spine, I have done my job.
Thank you, Dr. Singh.
Yeah. Okay, yeah, sure. Couple of examples. So at the college, we do more of applied research than discovery research, right? So we essentially use an existing technology or we improvise it and use it for a different application. So there are two examples I can think of. So the first thing that we did is we worked with a local aerospace company, Standard Aero, where they repair engines. So we use a technology called cold spray. I'm not sure if everybody knows or understand. So essentially what it's an additive manufacturing process where you inject solid particles of any metal onto an alloy, right? So you cannot weld an alloy because it's reactive. So this is the only way you can actually repair those components. So we use an existing technology which was used for a different application onto repairing aircraft components. So based on that, the company was able to save a lot of time and money using that technology, right? So that's what the kind of research we do. It's all applied on a real-life problem. And the second example that I had mentioned was coming up with an electric bus. And also a very different example I can think of is we also have something called Prairie's Research Kitchen, where we innovate anything related to food. So we were the first ones to invent or discover how to use fava beans to make tofu. So those are soy-free, so allergen-free tofu that was developed at the college. Right? So we use Manitoba-grown fava seeds, fava grains. Yeah.
As a vegetarian, he loves it. And so do I. Maybe I'll give an example, like somewhat similar to Red River. We also do applied research. So we work with companies to solve their problems. And this particular one is with one of the larger companies, and it's in Cameco. Most of you probably know Cameco for the work they do in uranium mining. And this was our director of DICE. Do you want to stand up? I want to give you the credit there. He was involved in this particular research. So this was at IMII. It's International Mineral Innovation Institute. And there were some conversations happening around some of the challenges the industry was facing. And in particular, Cameco does mining using some jet boring mechanics. And they were having some challenges in terms of the percentage of accuracy that they had when they were doing their mining operations. So using AI, we worked for over 2 years. This particular, I think it was over 2 years, operation to create over 90% accuracy in their mining operations, which saved them a lot of time and a lot of money. Under NDA, I can't share how much. But yeah, there you go. Well, it's Cameco, so like, but again, started with a conversation. A lot of effort went into it, but the results of the ROI was really remarkable.
Amazing. Dr. Whedon?
Okay, so since I initially had an example that is dollar-wise, but I'm going to end on an example that is not dollar-wise. But for the most impactful innovation at the University of Manitoba, I can show you this phone. It's not Apple, but the technology that makes you not pull the antenna out anymore, that is a University of Manitoba invention. So the technology not only allowed us to shrink the phone and don't have to pull the antenna out anymore, but it resulted in the formation of about 15 companies that are built on that IP that commercialized and brought value to the province in the billions of dollars. Okay, so that's the whole pipeline that we're talking about, feeding students, running the companies kind of thing. But the example that I would like to do within in the context here on the messe is, again, an idea starting, I guess. It is a fashion company. And so I had a nuclear physicist working in architecture talk to us about the fact that she has a metal allergy and she wanted to wear a necklace, which she could not have, but she decided to build this out of felt. But you cannot cut felt in that precision that you needed to build jewelry or necklaces around it. So she reached out to a German company to build a technology to help to process the felt. And so based on that technology, she started her company, started her business, and about 6 weeks ago, she showed at the New York Fashion Week her fashion line out of this. So I think that is bringing me back to impact. I think that's great impact and nicely highlights how the innovation ecosystem ties over to expertise in the manufacturing sector that resides in the German ecosystem here, for instance. That's a natural fit.
Perfect, thank you. I mean, all pretty unique examples and success stories. So that's it for us. We're at time. So obviously I wanted to thank all 4 of our speakers. I know you're very busy here this week, so to take the time to do this, we very much appreciate it. I want to thank the Government of Saskatchewan, Government of Manitoba, and obviously, again, ISED, NGen, and Global Affairs Canada. So thank you all for coming, and I hope you enjoy the rest of the show. Thanks. Thank you.
on the planning call together.
Guided tour.
And I think their business model is really good. And our organization, they have a panel all organized in the best way. All provinces of some with prime minister, some with the minister. I mean, it's a really good approach.
Yeah. It works well. It resonates well. People feel comfortable there.
Yes.
There's lots of dialogue.
Yes.
That's what we need.
I interviewed your CEO yesterday.
Yeah.
I was the moderator for the panel of the Business Council of Canada.
With Linda.
Yeah.
How did it go?
I went very well. But you know what? What's funny? You know, executives, they were all CEOs, okay? So they're used to give an answer in the least amount of words possible. So I had like 5 very good questions, and you could expand at your will. So first question, is the CEO of Business Council, 25 seconds. Then the president wants to expand, another 25 seconds. The other guy from the mining company, so it's been less than 2 minutes, and we are finished with the first meeting because everything has been said in least amount of words possible, and it's perfect.
People have to have scripted answers. They know what you're waiting
Yes.
for. And they have a perfectly scripted answer. Where every word is...
It was a masterpiece. And then the second question. Look at my watch. He's been only here 15 minutes, and it's a 40-minute. So let me tell you that it's a good thing I'm good at improvising because I came up with themes, and they love it. Integration, talent, whatever. Bring them on. After 40 minutes, I succeeded in keeping them on safe for 40 minutes. And we're very happy, and what's the name of the CEO? I forgot his name. I think that's it. He was very happy after that. They're incredible. They're mastering every culture. There's nothing that can take them off. So comfortable with anything, and they have a position. No, it went really well. It was really
Yeah. Sometimes another trick is to let them have a dialogue with each other.
Okay.
No, it's gonna be great. Wait, is that you here? Oh, Rafal is there.
People already seated, or you want to, he's going to call them on stage?
I think they can sit already.
Yeah, so anytime.
And he'll be introducing them.
I will introduce only Adriano, and he will take it from there, and he will introduce. Can I take his glasses, please? He will introduce the panelists.
Okay.
So anytime it's almost. I will introduce Adriano here and the theme, and when he's going to come here, he's going to introduce the panelists. That's good. Okay, so if you can all be seated.
Slower. Hi.
I was a chief during the pandemic.
Oh, yeah.
Real intense. All right.
So, Doris, you have your microphone. Then that's your microphone.
I was going to stand.
Check, check.
Good afternoon. So the next presentation, the theme of the next presentation is Innovation in Ontario, Transatlantic Perspective. And I'll invite Adriano Visa, the Executive Director in partnership of the University of Toronto, to moderate this panel. Thank you.
All right, thank you very much. And it's a great pleasure to be here today. I just want to extend a really warm thank you to all of our hosts here and to NGen and ISET for organizing this for Team Canada, and also to our German colleagues and friends here. Thank you for the warm welcome. We really feel like we're among friends and allies here. I'm really delighted to be moderating this all-star panel today on Innovation in Ontario, Transatlantic Perspectives. The province of Ontario is an economic powerhouse that supports a multitude of thriving industries. Canada's largest province and economy boasts robust sectors such as automotive and mobility, life sciences, mining, technology, construction, agriculture, and food. And in advanced manufacturing, which is a key theme of this show, the province features more than 20,000 companies, forming a strategic cluster. In recent years, supported by deliberate initiatives by our provincial and federal governments, Ontario, specifically the City of Toronto, has emerged as North America's second largest tech ecosystem and the fastest growing over this time. Ontario has seen $13.9 billion in investments over the last 3 years, in tech investments over the last 3 years, features 22,000 tech firms, and is the best educated jurisdiction of OECD countries with more than 70,000 STEM graduates every year. This has been evidenced by the significant investment in multinational enterprises in AI labs headquartered in Toronto, leveraging the deep talent pool and knowledge base that exists there. Examples include Google, Unilever, NVIDIA, LG, and many more household names. A robust community of startups in the AI, ML, and quantum space, and we have one with us here today, really have created a dynamic ecosystem and are putting Ontario on the map. So U of T, where I work, is one of the linchpins of this ecosystem. We're Canada's largest university, nearly 100,000 students, #1 ranked engineering school, and computer science and medical schools, top 10 in the world. We attract some of the most promising minds from abroad in our own backyard, and we train them to go out and become thought leaders, change makers, and ambassadors for Ontario and for Canada. And here in Germany, we feel that Europe and Canada, Germany and Canada, we're natural and complementary partners. And in today's world that's changing every week, it seems, that takes on an even more important meaning. So learning from each other, helping each other, collaborating, finding mutual benefit and value, that is why we are here in such force this year. Not only to make an impression, but to continue building our international partnerships brick by brick and leave here with concrete, actionable outcomes and collaborations to develop. And I think we have the perfect people on stage today to talk about just that. So let me introduce our panelists, starting with Rafal Yannick, the Chief Operating Officer of Xanadu. He leads the commercialization of Xanadu's quantum computing technology, has over 15 years of experience leading software and AI teams in large enterprises and high-growth startups to bring cutting-edge technologies to market. Rafal holds an MSc in biophysics from the University of Guelph. Seated at the end of the row is Rad Kadri. He is the head of the Ontario Vehicle Innovation Network, also known as OVIN, the Government of Ontario's flagship initiative for the automotive and mobility sector, and VP of Strategic Initiatives and Business Development at Ontario Centres of Innovation. A dynamic leader with a vision for propelling Ontario to the forefront of innovation, Rad is the driving force behind initiatives that shape the future of transportation, industrial technologies, and other key drivers of growth. Under his leadership, initiatives such as OVIN and the recently launched Critical Industrial Technologies stands as testaments to Ontario's long-standing role as global leader in automotive, mobility, and industrial technology innovation. His tenure is marked by a relentless pursuit of excellence, championing highly successful programs that catalyze the growth of Ontario-made innovation. From early-stage technology development to commercialization beyond borders, talent cultivation, key economic outcomes including job creation and follow-on investment. As Rad looks to the next generation of innovation across automotive and mobility, industrial technologies, and other emerging sectors, his unrivaled passion, dedication, and commitment to pushing boundaries underscore his role as a trailblazer and forging the path to a brighter and more sustainable future for all of Ontario. Right next to me, I'd like to introduce Vivek Burhanpurkar, the CEO of CyberWorks Robotics. Vivek is one of the founding pioneers of the field of autonomous mobility. He's credited with writing the world's first academic thesis paper on indoor autonomous navigation for dynamic unknown environments while at U of T in 1984. He also published some of the earliest scientific research papers on the topic in peer-reviewed SME and IEEE journals and international conferences. He also served as managing director of CRS Robotics, a TSX-traded tech company with over 300 engineers in Toronto and Stuttgart. He's responsible for expanding CRS into Asia and Asia Pacific, and Vivek currently serves as founder and CEO of CyberWorks Robotics, which is a globally leading provider of breakthrough autonomous self-driving technology for third-party industrial products, ranging from people movers to floor scrubbers, in partnerships with global corporations including Linamar, Somimoto, Bosch, and others. Vivek has worked with top-tier leaders ranging from heads of state to Fortune 500 CXOs across the EU and Asia. And last but not least, I'd like to introduce Joris Meine, Senior Vice President, Digital Industries, Siemens Canada Limited. Joris is SVP Digital Industries at Siemens Canada. Siemens Digital Industries business is an innovation and technology leader in industrial automation and digitalization in both the discrete and process industries. Mr. Meine is responsible for the overall strategic direction and management of the division, including sales, marketing, and service operations. Mr. Meine began his career as an electrical engineer with Siemens in Brussels, and then he was the business development director for automation at Siemens head office in Germany, covering Asia, Africa, and Latin America. Prior to his current role, he served as the vice president at Siemens Product Lifecycle Management Software, Inc. in Plano, Texas. So Joris, I'd like to start with you today. Calling on your extensive background and years of experience at Siemens, could you start us off by giving us some insight into how Siemens has grown and developed in Canada over time? Areas of business that have become important for the company and our country, and how Ontario's innovation and business ecosystem has contributed to support this.
Well, we have a long-standing history in Canada. We are in Canada for more than 110 years. And even before that, and that even further in history, we were the first company that connected the two continents, Europe and North America, with a telegraph cable. So it was not a digital connection, it was still an analog connection, but at least we built a communication line between the two continents. And then from there, we have grown first in Montreal, and then we came to Ontario. We continue to grow in Canada, and of course in new fields. And these fields are really in the areas of the digitalization, and I use that a bit as an umbrella. And we operate in different industries, of course. We have a separate company in the healthcare business. So for those that know MRI machines, that is our healthcare business. We have also a manufacturing there in the point of care area where blood sampling can happen with a small device, and you get an instant result. So you don't have to wait your 2 days to get your results. So these things are manufactured in Ottawa, for example. We have then a train business. The future Via Rail trains between Quebec City and Windsor will be Siemens trains. Also a strong presence there. We are in one of our larger divisions is in the infrastructure business. More than 1 out of 3 panel boards in your house in Canada is a Siemens panel board. And also in the building automation, the more intelligent systems, we are quite present. And last but not least, it's in the industry. And that's in our business, both in the manufacturing as in the process industries. A lot of that emphasis has shifted towards more software. We have more than 300 people active in our software business, most of them actually in R&D. And there are good reasons why Siemens globally has chosen Canada as one of its key countries to invest in R&D. Of course, first is the strong universities. It tends to be a place where young people want to emigrate to, so we are very friendly. Also, the culture is welcoming, not just for the smart person that universities want to attract or businesses want to attract, but also to the spouses. One tends to forget that. Attracting talent is one thing, making sure that they hang around, literally, is another one. And that's critical, especially for R&D, that people feel well on the campus or around the campus and can build a family there. And then, of course, not to be underestimated, is the proximity to the US. I mean, we should not forget that. And the fact that Canada is a promoter of open global trade. Yeah, also key component. R&D and doing R&D in Canada is still affordable, unlike some other jurisdictions which have been famous for R&D, but not so much anymore. So, and that's where Canada and especially also Ontario stands out.
Thanks, yours. Rod, I'd like to move to you now. You've been a public sector leader in Ontario's innovation ecosystem for several years. You've overseen several compelling initiatives and attracted significant investment to our province. So building on what Yoris just shared, can you give us your take on what are Ontario's competitive advantages? How does OCI support those to respond to emerging trends and grow critical sectors of the economy?
All right. Testing? There you go. Well, thanks so much. I guess going off of what Siemens said, and having great companies like Siemens contribute to our innovation ecosystem has been very fruitful for us in the province. You've got companies like that, and if you look across the last few years, and I'm mindful that a lot of the colleagues in the room have been big contributors to help attract that investment. We have Invest Ontario in the room. We've got our export development branch. We've got our colleagues from ISED there. This is a big team effort. But those investments, what we've been able to do in Ontario is not only attract them so that they can invest in our province and create jobs and create technology and export from Ontario and Canada, but they've also, through initiatives like OVIN and the Critical Industrial Technology Initiatives, what we've been able to do is capture that energy, that investment, and get them to come help us build up our companies. And I think, somebody said this on the last panel, we are a province, a nation of small and medium-sized enterprises, but we do need big players like Siemens and in order to help us build up our ecosystem. And so we've done that through OVIN. We've worked with our colleagues across the province and federally to bring those investments in, but more importantly, help those investments help us build up our ecosystem. Our universities, our talent pool, our small and medium-sized enterprises, our adoption of technology across our municipalities, our roadways. I think how I would put it is it's about capturing the energy of big investments and making sure that not only it supports its own job creation, but it helps us to multiply that job creation across Ontario. And everything we do, and I'll give you an example through OVIN, is when we support a small and medium-sized enterprise through funding, they need to have a customer in hand to help them pull into the global market. So we really are leveraging what we've been able to accomplish as a province, as a country, to really build up our companies and get to the market. And then we've put together a set of programs that take them through the entire journey that they would have to do from just our launch of the OVIN Incubators Initiative, and that was in partnership with our colleagues from Mercedes-Benz, and Annette was just here with me, great partners, Mercedes-Benz, our first partner, not our only partner, to help us start new companies in Ontario, to help us support entrepreneurs to take that leap. Then you go on to our R&D Partnership Fund that helps them develop their technology with a customer. Then you go into our talent initiative, which helps them attract talent to build up their company, but also keep that talent in our province, in our country. To our regional technology development sites, where we've brought all the resources across regions to help chip in to support those small, medium-sized enterprises. To our demonstration zone in Markham and Vaughan, and I see our colleagues here from Vaughan, that provide a platform in the city centers to demonstrate made in Ontario Canadian technologies to the world. And I think that's important. To our piloting zones, which is supported by the federal government through FedDev Ontario, where we've now partnered with the City of Toronto. We've partnered with the Blue Water Bridge, and not going to tell you any secrets. We have a bunch of other partners to announce. Major infrastructure in our country that we're using to help our companies take that last leg into industrialization. And then all the way to OVIN going global, which is about us getting our companies to market. So we have a great partnership with the state of Baden-Württemberg. We've signed a partnership with Taiwan. We have others that I'm not going to announce here today. And so the idea is we've really thought it out very well, but the strength behind what we do is it's all of us working together to build our companies and get them to market. And I think now more than ever, and you probably heard that 50 times today, and you'll hear that 50 times going forward, it's time to unleash Ontario, unleash Canada. This is our time, and we're going to push harder than ever.
Absolutely, absolutely. Thank you, Rad, for that amazing overview of what Ovid and OCI is doing to support innovation and growth in Ontario. Vivek, given Rad's comments on innovation in Ontario and CyberWorks' deep history in the province, having started all the way back in 1987, please help us understand, like, how has your company grown and navigated, and that pun is fully intended, by the way, the robotics industry? How has that industry, specifically in Ontario and Canada, matured to where it is today? And sort of, what are the key elements of Ontario's business and innovation culture that have fostered that growth?
Well, thank you. Thank you for those questions. To a large extent, just what you just said. CyberWorks has been a partner in many of Oven's programs. So, kudos to that. The other point I think that's important is that Ontario, I think, is really the center of the universe for AI. We invented it, right? Back in the 1980s, Geoffrey Hinton was inventing neural networks at University of Toronto. Lesser well-known fact, at the same time at the University of Toronto, there was a professor called Casey Smith, who is chairman of the Department of Electrical Engineering. He had a student that was writing a thesis paper on a different kind of AI for autonomous mobile robots in unstructured dynamic environments. I forget his name, but something, Vivek Burhanpurkar or something. So, we invented that industry in Ontario, and now autonomous mobile robots are everywhere. It's a big thing. Everybody's trying to do it, but it started in Ontario. So I think we have the ecosystem, we have the innovation in terms of the growth of CyberWorks. We really have. Part of our DNA is really partnerships within Ontario, partnerships with groups like Oven, but outside of Ontario, we partner with companies all over the world. We're talking to global brands like Bosch here in Germany, Sumitomo in Japan, Linamar, and so on and so forth, and that leveraging their capabilities to rapidly expand the use of our technology in a wide range of industries.
Great. Thank you for that insight into how partnerships are helping the CyberWorks. I want to stay with you for just a second, because you do have a little bit of business history with Germany, don't you, and some connections. And so can you tell us a little bit about your interactions here, which go back quite a few years, and what is interesting about the German market?
Yeah, we also, I've been an entrepreneur for a long time, and back in the 80s, I actually started the world's first autonomous robotics company. And at that time, even then, we were working with companies all over the world. We were heavily criticized in the 80s for doing that. Everybody said, no, you shouldn't go overseas. You shouldn't, you should stay in your own backyard, all those sorts of things. And we didn't listen to that. Our first sale in the 1980s of autonomous mobile robots was in Holland. Our second sale was in Germany. Our third sale was in Japan, and these were big numbers for those days. So it's part of our DNA. Where it's wonderful that we're back here in Germany, working with companies like Bosch and other German companies.
Great, thanks. Rafal, over to you. So we're moving from a Canadian company with deep history in Ontario to in CyberWorks to Xanadu. One of the province's most recent unicorns, that's for sure, and a great example of homegrown innovation and entrepreneurship in Ontario. So Xanadu now being one of the most highly valued quantum companies in the world, and really a main character in Ontario's story of emergence as a tech hub. So a couple topics to explore with you, Rafal. First, please give us a sense of Xanadu's origin story, and how our Ontario ecosystem has helped the company's founding and growth.
Yeah, absolutely. I mean, without the great academic investments in quantum in Ontario, Xanadu wouldn't exist. We're a little bit different. We didn't actually start in a university and transition that technology out into a corporate entity. Everything we did was within the confines of Xanadu, but uniquely all the talent that we had was either trained at the University of Toronto or University of Waterloo in those early days. We've expanded, and of course we're recruiting from around the world, and in fact that's been another massive benefit to being in Ontario. 52% of the people that work at Xanadu today, we've brought in on various different visa programs from around the world, from Germany, from Japan, from basically anywhere where we can find that talent, because the talent is so highly specialized. And the really kind of unique thing is, even though we've had to bring them on visas, many of them were actually trained in Canada, doing their PhDs or postgrads right our own backyard. Early days, we really relied heavily on programs from OCI in order to let us understand things like how do we capture IP and get the training that we needed as scientists who didn't have that operational knowledge early on, and be able to actually move into functioning as a real company. And now as we're scaling up to things that are much larger, we've been able to kind of stand on the shoulders of giants. There's a lot of great things happening in Ontario right now, but historically, we've had a little bit of trouble commercializing. Whether it be the Avro-Aero and the aerospace industry, whether it be the optical telecom industry and what happened with Nortel, all the way to AI, which I would say is a partial success. We did a great job developing that, but maybe not a great job industrializing that. But we're really lucky to be where we are right now, in that I find Ontario really understands not just how to do the development piece now, but through a lot of really hard-learned lessons, now understands how to actually take that and industrialize and commercialize that deep tech research, and is now coming to grips with the really hard choices in the absence of maybe a very large market just right on your border. What type of partnerships do you need? How do you raise that capital in order to actually take those innovations and move them to real product?
Great, thank you. So I want to stay with you, Rafal, and switch gears a little bit, but help us understand quantum a little bit more, right? It can be a little bit complicated, to say the least, when trying to understand the principles behind it. But in terms of applications, can you just break it down for us, for the audience? What is quantum computing fundamentally? What will moving from classical computing architectures to quantum achieve? And what value do we see it generating for industry in the future or already now? How is Xanadu moving the needle on maturing this technology and deploying it?
You have the wrong person. I'm like a quantum pessimist to the point that my wife actually questions if I actually work for a quantum company. Quantum computing is just a completely different approach to computing. It works on very different mathematics. And for a large subset of really, really hard problems that we're facing today as a society, those problems become intrinsically easy for a quantum computer. So it's not that it's faster, it's not that it's massively parallel, it's just that the fundamental physics and mathematics of how it operates makes a lot of large problems really, really small. And some of the problems that we believe early on we'll be able to tackle with quantum computing are problems in the materials and chemistry space. And this is kind of a natural extension. Those problems rely on quantum mechanics, quantum computers rely on quantum mechanics, so you should be able to move the needle forward on those. One thing I really want to highlight is a position that we hold at Xanadu, I hold personally, and I would say most of the scientific community holds, which is that today's quantum computers are not useful. In order to build a useful quantum computer, there's still some technical challenges to solve, but this is what we're moving towards in the industry in the next 3 to 5 years to really have. And I really want to highlight that unlike AI, where we had a ramp up since the 80s of capabilities, quantum computing is really a step function, and we don't have it right now. And once we have that device, we will have it. And there's some really fundamental problems we'll be able to solve and transform industries. Maybe it's a good time to highlight the work that we're doing with Volkswagen, which is really focused on simulating some of those core materials that are used in batteries in order to more quickly bring batteries of greater range, of greater safety to market than we can today. And the idea is that today's simulation methods on regular computers, and by regular I mean the world's largest supercomputers that we have, just do not have the precision to be able to simulate batteries in order to remove the wet work, the actual work in the lab that happens. What we believe with our approach, and we've now patented a number of applications with Volkswagen, once we have our device online, we will be able to move the majority of the work from the lab into silico on our quantum computer, greatly reducing the cost and time to market for new innovations. And it's not just batteries, it's really all materials. We're looking at light-emitting diodes, we're looking at sensors for automotive applications, we're looking at materials in the defense sector as well with various partners around the world, and these will be fundamentally transformative to a broad range of industries.
Fantastic. Thanks, Rafael. Okay, yours. Back to you. So the extent of Siemens' business, it's truly impressive. It reaches markets like industrials, infrastructure, healthcare, manufacturing, transport, to name a few, which you did earlier. I can't help but notice this really aligns with Ontario's economy and talent pools. So while we've established and we're growing world-leading ecosystem around AI and quantum, as Rafael just mentioned, Ontario is somewhat of an economic decathlete at the same time, right? Like all the sectors I mentioned above are playing a big role. So can you comment on the benefits of doing business in Ontario for Siemens, both from the perspective of new and emerging technologies, but also from the perspective of the strength in our traditional industries that make up your end user markets?
I will give a very short answer that gives me a little bit of airtime because I have a question to ask to you that I would like to...
No problem.
Yeah. Okay, so Ontario investment, as we speak, we are investing in R&D in the battery production and in the field of AI. Many battery producers are struggling with the quality consistency. There is a lot of scrap created in the process, so it's not a repetitive process enough. So that has to be increased. And the trick here is to crack the code, is to find early in the production cycle that your batch is not of quality that will lead in the end to a good battery. So AI comes into play, and that is the R&D work, which thanks to the support of the Ontario government and the federal government, that we are setting up in Ontario. The second task we have is to help build an ecosystem, because we have in Ontario, we are blessed with an automotive ecosystem. Cars are changing to hybrid, are changing to full electric. It's going to happen. It might go a little bit slower, but it's going to happen. And that means that poses potentially a threat unless Ontario is shifting gears, actually getting rid of the gears at all, and moves to electric vehicle. And that is important because 700,000 people directly or indirectly thanks their employment to the automotive sector. So that is a critical success factor for the prosperity of Ontario. So that's it. And I want to ask actually you in quantum technology, because that interests us a lot. You mentioned also battery. What are the hurdles? What are the obstacles to scale?
Yeah, that's a really interesting question, and the answer depends a little bit on how you're building a quantum computer. So quantum computing really just relies on controlling matter at the finest level of detail with the greatest level of control. And some people are doing this, like IBM, building superconducting circuits. Some are doing it on actual controlling individual atoms with approaches like neutral atoms and trapped ions. IonQ, QEra are two different companies in that space. We do it in light. So we actually have a photonic approach where we have integrated circuits that are channeling light at the quantum level that we're able to leverage to have our quantum computation. until actually recently our paper in February of this year in Nature, one of the biggest challenges was understanding how to have a modular architecture. So quantum computers that work independently, but that are connected together through quantum channels. And this was because if you're going to scale this system large enough to solve real problems, it's going to be a data center. You cannot build a monolithic chip that big. This is for photonics a solved problem now. For the other approaches, it's still a pretty big challenge that they're looking to tackle. And in the photonics space, really the one remaining challenge is the quality of the manufacturing for the semiconductor platforms that we leverage. So without getting to too many of the specifics, we're aggressively pushing with our partners here in Europe, in the US, and in Taiwan, the ability to manufacture not smaller feature sizes like companies like NVIDIA are with TSMC, but actually higher purity materials with greater detail in terms of the quality of features that are actually manufactured in order to reduce the noise in our system. And we believe that over the next 18 to 24 months, we'll qualify those manufacturing processes and actually be able to scale up into a manufacturing mode to build that data center to deliver on those promises.
Is that a good answer? I think so.
Thank you.
Thanks, Rafal. Okay, Rad, back to you now. So I hope at this point in the panel, we've begun to convince our audience of what Ontario can offer to the world and why we are a committed and stable partner in business. So current geopolitical events, of course, cannot be ignored by any of us. And they drive us all to seek like-minded partners in business and international relations. Then if we look closer at German and European industry, we find that there are several complementarities between the industrial excellence they've established over decades and Ontario and Canada's upward trajectory over the last 10, 15 years in Industry 4.0, right, in high-tech domains. Not to mention our abundant natural resources, of course. So from these dual perspectives, like first, the wide lens of international relations and alliances. The second, our industrial complementarities. Please share with us your view of what makes Germany and Ontario, Canada, a natural fit for partnership.
Well, I mean, I think you said a lot of it there. I would say that Germany, the rest of the world needs Ontario technology. We've got Xanadu, we've got CyberWorks, and we can list another, 500, 600 companies in the automotive mobility sector, and those are just the ones that we're able to see. There's always new ones sprouting up, and then take it across agri-food, mining, advanced manufacturing, construction is a big area now, life sciences, healthcare. I mean, wherever we go, everybody recognizes that we're always coming up with the new things. Our technology, our companies are innovating. They're bringing new things to the world. We talked about how AI started in Canada and Ontario. Didn't start there, but you get the gist. It accelerated there. Is that fair to say? So take that and say what are the complementarities? You have in Germany a nation that's full of great companies that are leaders globally, and in order to stay at the forefront of leadership, they need to partner and to source from Ontario companies that are going to help them leapfrog their competition across the world. And that's not just for Germany, that's everywhere. And going back to everything you said, like I said, the time is now. We have to take the opportunity. We should have taken the opportunity a long time ago, but I think this should be the impetus, the catalyst for us to say, you know what, no matter what, and it'll, no matter what, we're going to keep pumping our companies to the world. And I am going to point out, we've got representatives, Ontario has representatives across the globe. We've got Ernst over here and his colleagues, right, that represent us, that further Ontario's companies' positions here, that make the connections, that make the linkages, and that provide the pathways. We've got initiatives like Going Global. I'm pointing at my crew over here, that we're creating new partnerships to what we call create highways to get into these jurisdictions with great partners like eMobile BW, who we're going to be with later today, the state of Baden-Württemberg, who, what a great partner. We sit across the room and we say, what do you want? What do we want? We want Ontario companies to get to market. We want you to help us find companies that want to buy from our companies, and we want to put them there. What do you want? We want to be a good friend to you. What a great partnership. And they haven't asked for anything but friendship, and I think that's fantastic. Not to say we shouldn't do more. And so take that, create more highways. Let's create a pathway for our companies. Let's plow the way for our companies to get to new jurisdictions, to get to new companies. And we've got Ontario has representatives, Quebec has representatives, but we also have global affairs who are all over the world, and that's their job, right? And so let's leverage that. Let's push a little bit harder. Let's work together. Let's find new pathways. Let's create new opportunities. And I can tell you, through going global, we've got like 5 or 6 new agreements where I can tell you our focus is very, very diligent, and we want our companies to get to market. So help us get there.
Fantastic. Thank you, Rad. Okay, Vivek, let's talk about autonomous mobile robots for a second. All right. They've been around for many years. Right? As I mentioned before, CyberWorks has been in business since the 80s. So AMRs, or autonomous mobile robots as they're known, are a hot topic in the media, right? But their deployments, they seem a bit limited. So we don't really see these deployments happening in en masse across society yet. But what's holding things back? When will we see increased adoption, and what pieces are missing to achieve this widespread adoption and ubiquity of AMRs?
Great question, and I think there's a strong parallel between quantum computing and AMRs in terms of public perception versus reality. In the area of mobile robotics, there's a lot of media hype that makes it look like there's a robot revolution going on and robots are going to be ubiquitous, and if that were really the case, then you would see them right here, right now, and I'm looking around and I don't see one. So there's clearly a disconnect, and although the potential exists for autonomous robots to be ubiquitous, there are a number of what we call in our industry edge cases that cause conventional robotic technology to fail. Autonomous robots can get stuck, they can get lost, things like that, in circumstances that are not always predictable. The media sometimes calls them hallucinations. These are the problems that are really limiting the mass adoption of autonomous robots. One of the things I often get asked, well, what has CyberWorks been doing for all this time? Why haven't you solved the problem? Well, we believe we have solved, to a large extent, the problem of edge cases. This has been a recent development for us, and we hope that this is going to really revolutionize or accelerate the so-called robot revolution, the mass adoption of robots, and our strategy, our business strategy as a company is to license that innovation, that breakthrough, the solution to edge cases, to other AMR companies. So we hope this will dramatically accelerate the mass adoption of autonomous mobile robots to the point where you will see robots here, everywhere, hopefully next year. I don't know, but maybe that's too quick.
All right, well, anybody who's involved with a robotics company, you come talk to Vivek right after this panel. He's got technology to talk about. Joris, we're going to finish with you. Siemens, as you know, is ever present at this fair, is a household name here. For Canadian innovators in this audience, please tell us, what's worth a stop at the Siemens booth this year?
Well, there are various topics. We got Sunday night an award for the launch of what is called a co-pilot. So we manufacture and produce PLCs, which are widely used in manufacturing, but also in the process industries. And to program that, you use code, but now you can talk in your regular language and let the co-pilot program that for you. a little bit of debugging, and off you go. So a serious time saver there. And for that development, which is an AI-based development, we got this award. So this is a proud moment. We don't win this every year, though, so this is really special for Siemens. Another highlight is we host 2 Canadian companies on our show, on our booth. The colors of Siemens are green. It's called petroleum green on a blue background. But don't look for these colors. Look for the red in the Canadian flag, and you will see right there on our booth where the Canadian presence is on our booth. We have 2 companies that we feature. One is in the sustainability area. That is a company called The Cultivated Bee. They produce alternative proteins, and alternative proteins are used. Yeah, we all think about that hamburger that you replace, but that's not what this is all about. It's on a much smaller scale for the production of gelatin, capsules, or as well in the pharma industry, yeast for the development of cheese and so on. And that this is done in what is called a bioreactor, and the control, the automation of that is a Siemens application. A company from Burlington is there, and another one is an iconic company from Quebec. They basically make machines that automate the sharpening of hockey skates, but then on a really professional level. If you have a favorite hockey player, look him up and you will see the size and the specifications of the hockey skates.
Okay,
Here we
well,
are.
I might have to talk to you about that one later.
Absolutely.
Because, all right, that's incredible. Okay, we're going to end the panel now, and I want to thank all of our panelists on providing really amazing perspectives on innovation in Ontario, what makes Ontario an attractive place to invest, to partner, and really so much of what we have to offer the world. So in closing, thank you to our panelists, thank you to our audience, great audience here. Thanks to the organizers of the Messe, the Canadian and Ontario governments, and to NGen, for being the driving force behind Canada's unmistakable presence here this year. Today we heard a series of diverse perspectives on how Ontario's leading innovation across multiple sectors, how our German and European partners are contributing and growing these connections to generate mutual value, and why we have the ingredients for compelling and successful partnerships. We have a diverse economy from natural resources to cutting-edge tech, robust R&D, homegrown talent, a stable place to invest. So let's make 2025 the year we build alliances to last generations. Thank you.
Si. Si. Sie. 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 Hey. So. Za. Hallo.
Ach ja. So, ich gehe noch mal ganz kurz Pipi machen.
So, 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 so. Ja. Ja. Ja, ja. So, so. So, so. Ja. Ja, ja. So, so.
ok, parfait. Bon, mais d'abord, toi, tu s'en viens ici, d'abord.
Ah, OK.
Excuse-moi, j'ai pensé qu'il y avait quelqu'un. Toi, tu es ici à 3.
Sorry.
And you are number 1.
Oh, wow. Lucky me.
Introduce it and give you the microphone after.
Mais tous les fans qui s'en viennent. Oui, est-ce que tu vas pas prendre une photo principale?
Il faut que je la prenne, on va la prendre avant, si tu veux pas prendre tout de suite,
Ah?
si vous voulez. Oh, et là, on a quelqu'un de parti.
OK. Parce que j'aimerais juste faire une petite, publication.
Oui, c'est ça, je vais la prendre tout de suite.
Avec ou sans le flag? Elle est allée chercher de l'eau, je pense.
Ah, elle pense qu'il y a de l'eau, hein?
Non, non.
Ah oui, l'ancienne eau est là. Ça, l'eau aussi, c'est occasionnel qu'on en a. On n'en a pas tout le temps. On ne sait pas quel est le critère pour en avoir ou pas en avoir.
On n'a pas été assez.
On n'a pas compris comment ça fonctionne exactement.
On n'est pas assez VIP pour avoir l'eau. Ouais, c'est ça.
Est-ce que vous voulez... je vais prendre la photo, je vais aller vous chercher un verre d'eau après.
Ah, OK, cool.
Je vais essayer en voyant. C'est pas la bonne slide, c'est pas la bonne slide. Wow. Mais non, je pensais qu'il y aurait juste la feuille d'érable, là, mais... C'est drôle de slide, hein. Ça m'a l'air d'être la bonne.
Ouais, mais au pire, t'en reprendras une pendant le panel. Oui, il n'y a pas de problème. Tu restes-tu tout le long du panel ou tu nous startes puis tu pars? Est-ce que tu nous startes puis tu pars?
Je pars tout, c'est ça.
OK.
Là, est-ce que je vais te chercher un verre d'eau?
J'en ai un petit verre en carton poche.
Est-ce que je vais vous chercher un verre d'eau?
Regardez, vous pouvez en mettre dedans.
Je vais vous mettre de l'eau là-dedans.
Oups. Ah, t'as un fan club, Magali.
Yes, and she's on communication, so that's... Merci beaucoup.
Ça fait plaisir, ça fait plaisir. Donc, on y va? Alors, bonjour. Rebonjour. Ça marche-tu? Marche pas, hein? Non? Une, deux. Un, zwei. Oh. Bonjour. Good afternoon. The next presentation is by the RCEI from Canada and LNI 4.0 from Germany. The theme is how does the Quebec, Germany digital product passport help in international supply chains? À vous l'honneur.
Yes, thank you very much. Ladies and gentlemen, welcome to our panel discussion. We want to discuss with you how the digital product passport helps in data exchange in international supply chains. And my name is Andreas Gatterburg. I will be hosting this panel discussion, and I'm very happy to introduce you to our distinguished panel of experts. First of all, Ms. Geneviève Bourgogne, who is working at DEL, the Développement économique de l'agglomération de Longueuil. I don't speak French. I hope I did not butcher it too much. I'm sorry. Next, we have Anja Simon, who is the CEO of the Labs Network Industry 4.0 based in Berlin. Welcome. And we have Magali Amiel, who is a Director of Goods Movement and Logistics Consulting at CGI, also based in Quebec. Yeah. Please welcome our experts. Thank you very much. And I would like to introduce our topics. So I fear we have to take some time. We also brought some slides for you. So here you see, first of all, if I pronounced everything correctly. And on the next slide, you will see what we are talking about. So Geneviève, you came here from Quebec all the way to northern Germany, but you are not the only one who does that. Goods take this route every day, produced in Quebec, being brought to here and then maybe even used in further product. What are the challenges when you actually try to move goods transcontinentally?
Yeah, with globalization, it's simple to move goods through custom and between countries. The challenge is more with data because we don't have any standardization. So there is a problem when with the format, the data format, the terminology, and the interoperability. It's a real challenge in our businesses. And the truth is, it's lacking standardization with the data exchange right now in the SMEs and all the businesses. So the important thing would be to work on an international standardization to help company between to be more compatible and to operate together. I was really interested for the IMX initiative. The International Manufacturing X work to develop a new standardization for data exchange that will help companies to do businesses between countries. And I think it will be really important to help our company to diversify their market and to help them to work together. So this kind of initiative will be crucial for the next step and to help with the data exchange between company and countries.
So if I understand correctly, moving the goods is not really the challenge, but rather getting the data across the supply chain. So for what use cases do we need that? Anja, do you have a suggestion what to look at?
Yes, we do have. Very important and very critical factor today is the carbon footprint of our products because of taking care about our resources. Globally, not only in one country, we have to take care about these resources globally, and therefore the identification of the carbon footprint is a key factor which is becoming more and more important. I think that is very clear for you, but how we can count this carbon emission, carbon footprint of all the single pieces and pieces of every product, that is really a mess. How to get the data, how to calculate the carbon footprint, and how to bring that together to the end product. And that is our common use case for our demonstrator, how it could be counted on a very simple logic, but with a very standardized format in the background, and how to bring that together. That is our talk today and also our presentation afterwards.
I see. And talking about the carbon footprint, Magali, you have a lot of experience in setting up and consulting people about supply chains. What is the relevance of the carbon footprint and the data exchange surrounding it from your perspective?
So, good afternoon. It's a really good question, yes. To Anya's point, of course, product carbon footprint is very important for organization. And for example, I want to start with one example. IKEA, a few years ago, was the first to start to implement a carbon footprint indicator if you want to get some contract with them to all the supplier because of the data quality, data exchange. And why it's more and more important for customer. I have a few reasons, and I took notes. I don't want to forget one. So first, if you want to do environmental impact assessment, you have organization more and more, they are looking for trusted data to do some assessment about the product carbon footprint. Second, compliance. We know that states and more regulation about the compliance on the product carbon footprint, and also especially to follow some trends, modern slavery and things like that. So it's really important to capture all the information from the raw material to the end of the cycle. And that's what we're looking for. Then we have also corporate sustainability. More and more, ESG is really important for organizations, especially if we want to have some funding. So you need to know what your tiers and partners of the supply chain, how does it work, and how does it capture the information. And finally, for supply chain, really important. Why? When you talk about transport and logistics, and even manufacturing and sustainability, yes, it's for the environment. But when you look at your processes, you have better efficiency, so you reduce your cost. So that's really interesting too for organization in a way to reduce their cost and gain some productivity. So on the aspect, that's why it's really important and relevant for organization to implement the framework of product carbon footprint.
Thank you very much. So we heard that it is important to be able to track the carbon footprint, but is there maybe even a solution how we can do that already, Anja? Do you have an idea how to do that?
That is really a very, very important question. And Magali, thank you very much to emphasize and phrase it in a very crisp manner. What are the levers, what are the advantages, and also what are the expectations in the future data supply chains. And indeed, there is an international activity, what also Geneviève mentioned before, to create a digital product passport. A digital product passport based on international standards is not a proprietary and locked-in standard for only one company, for only one country or continent or so. That is really an international standard where all data are organized in the same manner, in a very aligned manner to transport the data along the product supply chain to the next production step or to the consumer in the end. And this digital product passport was initiated by a global initiative. Wherever it was identified, that it doesn't matter. It's an international activity which now becomes a standard, and that is really very important. That all the small, medium companies and all the different suppliers of different parts can really rely on. That is a standard. That is a maintained standard, which is not only a small niche product or so, and they can participate in that. And the digital product passport, I think it's very important and the solution forward for a global supply chain, data chain. That would be my answer for the first time.
Thank you, Anja. Yes, very good. So we heard the digital product passport is relevant for supply chains. From the Quebec perspective, Geneviève, what are your thoughts on the digital product passport?
Yeah, the digital passport is really important for Canadian company. The DPP is not well known in Canada and Quebec either, but it will be mandatory to sell product to the European Union. So in the context that we have right now, we need to diversify our market. So this kind of example or showcase at AL2, it's really interesting because it will help company to understand why to go forward with the digital product passport because it will really help company to understand the importance of the carbon footprint, the sustainability. It will be really interesting to sell product to internationally in the European Union, but in other countries too. The DPP will be interesting. And right now, our company don't have a carbon footprint, don't have traceability data, and they have to adapt because it will begin for the battery sector in 2026. So it's tomorrow, and all of the other sector will come through either. So they don't have to wait at their last minute to prepare themselves. They have to began to do the right thing and the traceability of all their process. And it's for this reason that we chose this kind of use case. It's to help companies to grow businesses through other countries. And we chose the asset administration shell to help them to standardize their data and to give the right amount of data to the right stakeholder in the global chain. So with our use case, we will be able to give them a QR code, and they will bring back at home the DPP, so the Digital Project Passport. And I wish that it will inspire them to go through this kind of project in the next few years, because it's a standard that it's globally accepted. So it's the uncertainty is a killer for businesses, but it's a standard that it's globally accepted. So I think it will be interesting for the next step for companies that want to diversify their market, to go through this kind of project to help them to grow businesses between the European Union and Canada. Yeah.
So, Digital Product Passport implemented through the famous German asset administration shell is important for the international exchange. Magali, can you maybe shed some light on your practical perspective on this concept of digital product passport, and what do you think it means for actual practice with your customers and the companies you work with?
Well, for customers, depend where you are in the world, right? If you're in Europe, it's more advanced than North America, we'll say. What is really interesting about the DPP, and it's how you onboard all your supply chain in this process, because both Anya and Genevieve said, it's really about data, it's about trust. We have to trust the data that you put into the model to be sure that the information you get at the end is the right information for the industry. And sometimes, according to the industry you are working with, for example, for foods, it's more advanced because of the traceability. We want to know from the raw material to the final product. So the DPP is really interesting if you already manage and have a good understanding about who are your tiers around all your supply chain, from raw material to manufacturing to the transport, logistic distribution to the end user also, because you can measure, the energy to use your product. And also at the end, when it's the end of life for the product, how you back them into the circular economy. So all the process, you have to onboard several partners, and they are not all at the same maturity level. Yeah, both in terms of data, in terms of technology, in terms of processes and knowledge. So it's really an ecosystemic, approach that you have to onboard with organization. And when you have some organization, they are, for example, in Quebec only, other are worldwide. So how you match, all together. So that's really fascinating conversation that we have with our customer. And, to start, you need an ambassador. And I'm back to my example of IKEA. IKEA is a good ambassador first, because it's really the framework that it decided to adapt and to adopt for a customer. And what the DPP wants to do here, it's the same, how we are going to find an ambassador to embrace the project and onboard new players and the standards around. And I think standardization is really key. Collaboration, acculturation, and standardization really key to start this project.
Thank you. So it does bear quite some relevance for actual cases and actual companies. Magali, can you maybe elaborate even further a bit about the benefits you see with the concept of the digital product passport?
Well, I think I listed 4 benefits. First, transparency. really transparency in terms of data and in terms about what is happening around the supply chain is really important. Then all around the regulatory compliance, because you are going to have some fees or some, fees or states can ask you to pay because you don't follow what they are looking for. So really the benefits is having this compliance with government and other associations. Also, it's the carbon reduction strategy that you implement into your organization, and it's really strong. And finally, also, it's all about the brand. How, for a customer, in a customer side, you enhance the brand of your organization because you are following our, standards, you are compliant, and you provide information that really help the overall supply chain for you, the country where you are, and the global supply chain.
Thank you. And Genevieve, you already mentioned the whole topic of standardization. So talking about the benefits of the digital product passport, my guess is standardization is also important from your perspective, isn't it?
Exactly, and I think that it will help to secure investment for our company because we know that it's a standard. So our company know that if they invest in this kind of standard, they will be able to sell globally. So I think it's really interesting. They will know how to comply to their supplier. They will know how to sell. So this kind of project will be really interesting for them, and I think that it will bring them to be more sustainable. To rethink their business model, because it will not be only the more affordable product anymore. It will also the more sustainable. It will do a real difference. And I think with the green energy for Quebec company, it will be an edge for our company if they go through the DPP. And it will open a lot of market. So to do that, they have to comply. They have to rethink their supply chain, and they don't have to wait at the last minute. They have to rethink this right now because it's tomorrow that the DPP will be in application. So it's habitually our company wait at the last minute, but this kind of project takes really time. So it's important, I think, to think about the supplier, to maybe replace it with another one who have a more sustainable product, and after that, it will be easier for them to develop new markets. So I think it's a real advantage for us. And after that, I think transparency, traceability will be clear, will help with interoperability between companies. And with the standardization, it will help to grow businesses between countries too. I think it will facilitate, the data exchange, and with the good work of the IMX and the use of asset administration shell. It's a technical way to adapt them to the global exchange and to open the market. So it's for this reason that we did this demonstration, and we hope that it will open the eyes of a lot of Quebec company and Canadian company to begin each step, because the step it's not a short step. They have to rethink this. So we want to help them to go through all the steps and to collaborate with the ecosystem to open the market for to facilitate the growing emergence of our partnership with the European Union and to the international market.
Magli, you want to add to that? Go ahead.
Yeah, I want to add, because all about data standardization is really difficult, because finding a common standard to everyone, and I think you know that better than me. It's really, really difficult. So when we have one standard that can fit with most of the industry and organization, And we have to keep it simple. We really have to identify really the bottom line, all the information that we want to share, operational information really interesting, that we can trust, and easy for the organization. Because, for example, according to the size of the organization, that could be really difficult for them to onboard because I have for the DPP, it's this standard. For my client, it's another standard. For my industry, it's another. So in the end, you have nothing. So really how we can help and support organization with a single standard, really easy to implement. And also important too, we don't have to look at and standardize all the data. It's really the data were really important to achieve the goals. So the carbon footprint, operation, or other important, variables for an organization.
Anja, we are good on time, so if you want to add something to benefits as well, would be great.
I want to add something. I'm absolutely thrilled about this discussion because it was not prepared up front. And really, I like it very much. I remember the first time I met Geneviève, and Geneviève asked me, Anja, what is that beast, DPP? What does it mean? And is it really only in one direction between Germany and Canada, back and forth, or what is it? Could that open a door, or could that open a gate for our Quebec and Canadian companies to the world trade in regards of data exchange and so on? And then I promised, yes, Geneviève, that is not only in login in Germany, that is really an international standard, becomes an international standard. And we really try to convince and to the colleagues of Geneviève, and we try to explain what is the logic behind, what is that DPP standard, and which technology the asset administration shell as metadata model is supporting the digital product passport, because if you use the asset administration shell, this metadata model all over in the world, they can explain and can understand your data. So I'm sitting here, the ladies on the left and right hand side discussing as they have done it since several years. I'm really excited that we have really done a good job here to open the doors. And I would like to add something. It's a very first step with this DPP to join this international data exchange. The next steps would be to join international data spaces. What Geneviève also mentioned with this International Manufacturing X, that is an initiative to create also international data spaces where all these background technologies like the digital product passport with the metadata model, asset administration shell and so on will be used, and will also open up some more levers and some more gates for next trade opportunities, for next export-import opportunities and so on. But yeah, I can hear for the next hours to your discussion here, and I'm really excited about that. Thank you very much.
Yeah, may I add, because my colleagues here will say, Magali, you have to say that. We already did a DPP. Yes, Mario, it's because of you. Mario. No, we did a DPP for the automotive industry. So if you are interested to follow at the booth of CGI, all 17, we can have a demonstration about Katina X and what we did with the DPP, and you are more than welcome to look at how does it work.
Yes, because the best part is not just the many benefits, but that you can actually see it here, right, Anja?
Yeah, yes. And on the way to hall number 17, I will invite you around the corner how this looks like. This DPP, that is a QR code, a simple QR code, but not a simple, it's an industrial QR code, which is valid for 50 years, 50 years, getting older than me. This QR code, and you can reach out via this QR code, the digital product passport. You can navigate inside to the different parts and so on. And what we have prepared here, this is the welcome package you can see in my bag. And this is our surprise to you. If you could, or if you are willing to follow up us for the next corner, then we can produce for you a welcome package with this QR code and a nice pen and a nice phone holder and so on you can take with you and can think about what does it mean to provide not only the products around the world, also provide the data in a standardized format around the world.
Thank you very much, Anja. So you heard it. You are actually invited with a call to action here that you can see it for yourself right behind the mirrored cubicle over there. There is actually a demonstrator that already has everything running, as I understand it. And our panelists will be happy to go with you there once we are finished here. We still have some time, so...
Yeah, I can add something too on my side. What will be interesting is we will bring back this demonstrator in Canada. So we are a network through the province of Quebec. We have 4 industrial expertise centers. And if you want to see a real showcase and to be inspired by the numeric transformation and the digital shift, you can see a lot of technology and expertise to help you to go through this kind of project. We have a lot of experts, and we will bring back our partnership. And I think that if Canadian companies begin to do this kind of project, it will facilitate the collaboration between our 2 countries and to facilitate the diversify of market for our companies. So we will invite you at our booth at all too, but when we will come back in Canada, we can help you with that and begin the first step with you. So
very good. Yeah, I'm excited to explore all that together with you. This will be a great opportunity. I hope that many of you will join us to go over to the demonstrator in a few minutes. But first of all, we are still okay on time if you have anything to add, which you think we forgot before. Yeah, Magali?
Yeah, I think don't be shy to start this kind of process. Sometimes when we talk with a client, they say, "Oh, I'm not sure. It's complicated. I don't want to talk. Don't want to embarrass my tears with this kind of discussion, conversation." Don't be shy. Try, because you will be surprised. Sometimes you have a really small company. They are really agile and adapt really quickly. So I think the message is, okay, we want to achieve a common goal on the carbon footprint reduction, or lean processes or data sharing standardization. So it's really embrace the conversation with your client. And we have to do that more and more. We have to cut the fear, right? Sometimes people, they have fear to change because I don't know. No, just have a chat, a chit-chat, a good conversation, and that help to start really interesting projects.
Thank you. So you're supposed to not fear these developments. You're also supposed to not fear if you have any questions for our panelists right now. We would be happy to have any audience questions if there are any. But I think you were convincing enough that all questions are resolved.
So
otherwise,
maybe I would just add something else. If the Canadian companies often don't know how to begin the first step, but there is a lot of help in the ecosystem of Quebec that can help you through the process. So don't hesitate to come at our Industrial Expertise Center, or some of the Economic Development Corporation can help you with that, and we can really do a difference to help you to progress in your project and to work with the ecosystem like CGI and other experts, and we can help you with the carbon footprint, because if you wait at the last minute, all businesses will have the same project at the same time, and when all the project is at the same time, it will be difficult to advance. It will be longer, expand. It will cost more money. So it's the time to begin, and we're all here for that. So, yeah.
Perfect. Anything else to add from your side? Any questions that came up in the audience? Wonderful. So we will be happy to take you to the demonstrator right after this talk. Just stick around. I would like to thank you very much for your attention, and I especially thank the panelists here for the great discussion. Ms. Geneviève Bourgoin from the Développement économique de l'agglomération de Longueuil. Again, I'm not a French speaker, sorry. Anja Simon, CEO of the Labs Network Industry 4.0. And of course, Magali Amiel from CGI, who is a Director of Goods Movement and Logistics Consulting there. Thank you very much, and please thank our panelists.
Thank you.
My name is Andreas Gatterburg. Thank you, and have a great rest of the fair.
Thank you.
Thank you.
really close to the mouth,
Yes.
only then will they be able to hear us.
Well, it's better. Let's say it's louder. Like this
Well,
way.
we just talked about it. That
Yeah.
actually it's not very loud.
Yeah.
So
I will ask if they can
Yeah.
they can increase the sound, but it helps when you. A lot of people they like this, you know. That doesn't work like this. You have to.
yeah, we need. It's in licking distance.
No,
Ice cream
no,
distance.
not
right?
to that point.
Ice cream distance. Is this a camera? And is it
Yes.
recording?
Everything is recorded, and you will get the full recording. You can edit it. I think they will even make some edits, also small segment.
But it's not going to be broadcast.
Meine Damen und Herren, ladies and gentlemen, our second to last presentation of the afternoon, and not the least, because we're going to talk about quantum, which is, I would say, a hot topic right now. And the title of the presentation is How Basic Science Can Impact Business. And I'll now let you in the good hands of Dr. Marcela Carena.
Professor Doctor, thank you. Or just Marcela. Okay, so good afternoon. Thank you everybody for being here. And so vielen Dank. Vielen Dank. I'm here with three Germans. So vielen Dank, dass Sie bei uns heute hier sind. So I am Marcela Carena. I'm the Executive Director of the Perimeter Institute for Theoretical Physics in Waterloo, Ontario, Canada. And my role today here is to be the moderator, but also to bring perspectives from basic research into the quantum ecosystem. I am a theoretical physicist by training, and as a matter of fact, I was trained here in Germany. So I habe mein Doktorarbeit an der Uni Hamburg absolviert und danach habe ich meine Ausbildung an der Max-Planck-Institut für Physik und Astrophysik in München. Und über die Jahre habe ich mit vielen Kollegen aus Deutschland zusammengearbeitet. So ich freue mich sehr, dass ich hier heute bin. And that would be the last thing I say to you in German, so you are okay. So the other thing I just discovered is that at least that gentleman and this gentleman and myself, we were together over 30 years ago in Munich studying, and we are here today, so that's interesting. So going to my research, it explores particle physics and quantum information to solve problems of quantum theory in the early universe. So the Perimeter Institute actually is an academic institution, and what it's doing is, well, first of all, we are very lucky to have private and government funding. And 25 years ago, the Perimeter Institute became an early mover in the area of quantum information. So we have a long history. And today, we have, as I said, a long history of doing quantum information research and training. We have trained a lot of young scientists into quantum information. So what I wanted to say is that we do research in quantum information, research and training, and that really allow us to stand apart in the applications of quantum information for many fundamental fields of science and of physics, in particular in quantum matter, in quantum gravity, quantum foundations, and quantum field theory. And because of that, we have been able to contribute uniquely to applications of quantum information in areas that really bring technological advancements in quantum computing, quantum communications, quantum cryptography, quantum sensing, and metrology. So if you are interested in the technological end of all these areas, we are the scientists to come to talk to us. So today, we will hear from my colleagues here. We are very excited to be here today in this panel that is what basic science can do to impact business. And as we all know, quantum research is transforming industry across the world, okay? So here we have today three well-known leaders from Canadian academia and from Germany. And together we will try to discuss how basic research can be foundational in developing new technologies, and of course in solidifying Canada to be at the forefront of the quantum revolution. So without further ado, I will start from the far end, asking my colleague Norbert, and then coming around to introduce themselves and their institutions.
Okay. Yeah, thank you very much, Marcela. So my name is Norbert Lütgenhaus. I'm the Executive Director of the Institute of Quantum Computing. So I'm at the same time as well a faculty member at the University of Waterloo. And I'm working actually in quantum information since 1993. It's a long time ago, mostly on quantum communication, especially quantum key distribution, security proofs thereof. Our institute, the Institute for Quantum Computing, was founded in 2002. We work in close collaboration with the Parameter Institute. So what we are really doing, our institute is completely dedicated to quantum information. So we do the full breadth about computing, communication, sensing, but as well quantum devices and quantum materials. But as well, we work on full stack from very abstract questions to very applied questions, including as well spin-off companies. So we are like 30 faculty members. Overall, our institute is roughly 400 people that actually work in our institute. But we are we are a research institute within the University of Waterloo. So why am I as well on this panel? Well, one thing is as well that indeed I have been working on the basic research, really foundational research, but as well on application. So I've been as well working for a company in New York in the year 2000 to do the first commercialization project for quantum key distribution. And as well, I'm currently as well the co-founder and CTO of a company in Waterloo in the quantum safe cryptography area. So that means I have some experience, practical experience, to go from fundamental research to applications. Okay, thank you.
Norbert, thanks a lot. And I have to admit, I'm not taught or trained in Munich, but I live in Munich, so
So we
have something in common. Okay.
Good.
My name is Oliver Riedl. I'm the managing director of the Fraunhofer Institute for Industrial Engineering. On the same hand, I'm a faculty member of the University of Stuttgart, and there I teach closed loop system theory and control, so very mathematical. That's why Akim and myself understand very good on mathematics. So on the same hand, I'm the spokesperson of the Fraunhofer Lab for Applied Quantum Computing, which we funded recently, and it's not a misspelling. We call it flagship, and we exchange the G to the Q. So it sounds very good in German if you say it's a flagship, where we look after the applied research for quantum computing. So I studied technical cybernetics, got my PhD from the University of Stuttgart, and then I went to industry. So I'm not in basic research. I worked for a long time, approximately 20 years in industry, both in the computer science area and in the automotive industry. And my major focus in these days is to transport good findings from basic research to potential industrial applications, which is a major focus of the Fraunhofer Society. So we understand ourselves as the transport vehicle from basic research to industrial applications. So today I try to represent in that panel the application-oriented development of quantum software, because you're most in hardware, we are in software, you're in theory, but we talk about that later. And we focus on how we can develop today algorithms and applications knowing that the hardware is not, let's say, ready enough. We will talk about this error correction stuff, which the normal computers already have solved, which we have to solve in future. And we have already some experimental realizations with the industry, where the industry can benefit from the quantum advantage. And this we will talk later on. And now over to Akim.
Hello, I'm a faculty member at the University of Waterloo. I'm also a member of the Parameter Institute and of the Institute for Quantum Computing. My research is in the field of the physics of information. That's a very broad field of research. On the concrete end, we are considering, for example, how to optimize radar signals for maximum information retrieval. On the most abstract end of the spectrum, physics of information is about understanding the very laws of nature better using an information theoretic perspective. And one of the things we do is, at the moment, is applying a combination of AI and quantum computing. So for example, we developed a software package, a programming language for putting artificial neural networks on quantum computers. Google has adopted this software, and it's now an official Google product called TensorFlow Quantum. The reason why I am on this panel, as far as I understand, is that I'm providing an example for a new fruitful collaboration between the Canadian and the German quantum scene. So for example, we saw that, well, in Waterloo we have a lot of quantum theoreticians, and at the Fraunhofer we have quantum appliers, we have technology transfer. So for example, as you may know, in quantum computing there is no copy and paste. So in my lab we were thinking, well, maybe we can do something about this, and we found that we can copy and paste quantum information if it is suitably encrypted. Now that was a theory paper in January of this year, and now in March Oliver's lab at the Fraunhofer in Heilbronn and in Stuttgart actually managed to put this on actual quantum hardware and prove that it actually works on current day machines. You can do this. And this is, I think, good news for two reasons. One is that it opens up the possibility, it enables quantum encrypted redundant cloud storage. So you can store quantum information redundantly in clouds now. And on the other hand, it's good news because it shows the potential that there is in a collaboration between the Canadian ecosystem and the German ecosystems in quantum technologies.
Okay, so thank you. Thank you, guys. It's a pleasure to have you here today. So the idea that we want is to discuss a bit in this multifaceted quantum ecosystem, what is really the role of basic research into practical applications and into the technological scale-up that goes to industry. And I am, as you realize, on one end of this, and Oliver is on the other end of this, and Achim and Norbert are somewhere in between. That's what we are sitting this way. So I want to remind you, so that we think about what quantum information is telling us, that quantum information was born in the 1980s, which means it's younger than me, and most of the people sitting here, I think. So it's in this panel, not there. So basically, how did it come to be? It is important to understand that it came from the physics community, where they're trying to understand quantum mechanics and actually the role of quantum mechanics in gravity. Okay, gravity is what makes us stand here as we are today. It's important to understand how it works, and we don't know really exactly how it works. So that's one thing. And on the other side, it came the people that were doing computer science, the community from computer science. They were trying to understand better the limitations of information processing. So these two very different communities, when you think now we are going to from basic research to industry, but this started from very two different communities, from physics and computer science, and they converged together to understand that information works different in the quantum world. And this is really what quantum information means. And so basically, that means that they understood that they have to deal in different ways to understand how information works in the quantum world. And in depth, all the world we live in is quantum when you look at it with your microscope, very, very small parts. So basically, they understood that quantum mechanics, in general physics and quantum gravity, and actually the limitations and processing of information were very much deeply impacted by the world being quantum. And this is what started this field that this is the reason we are all here today in this Halle, actually. So if we reflect on the origins of the field of quantum information, then as you know, it divided in many subfields. The subfields that we know today are, quantum computing, quantum cryptography, quantum communications, and quantum measurements and metrology. So I would like to have one little example that shows how basic research from my side, and then I will go to Norbert. So that shows a very simple example of how basic research is actually impacting technology, okay, and quantum technology. So I'm a theorist, and therefore I ask myself questions about the universe. And the questions I ask myself is, what is dark matter? In case you have not heard what dark matter is 85% of all the matter in the universe. We, meaning you, me, the stars, everything, we are 15% of that matter. Well, it happens that we only know what the 15% is, and we have no clue what the 85% of that is. That's quite disturbing, I would say, I think. Do you agree? Yes. So that's quite disturbing, and theoretical physicists have been trying for 40 years to understand what is the dark matter. And we are trying to, we know that Earth plows through dark matter and it moves in the Milky Way, and yet we don't know what it is. So we are trying to look for dark matter in the laboratory. We are trying to create dark matter in the laboratory. In the CERN laboratory in Geneva, Switzerland, we are trying to create it. However, we have failed, and so we are trying to think different, as Steve Jobs would say. And for doing that, we are thinking about that dark matter may be very hard to pin down because it behaves more like a wave than like a particle. And there is where quantum technology comes, because in order to detect that dark matter, in case it is a wave more than a particle, we need quantum sensors. So atomic clocks, transmons, that are words that you may have heard, and superconducting qubits are at the core of experiments that we can use to detect this dark matter. And so theorists are working with experiments, experimentalists and with industry to build those detectors that are based on quantum technology to try to search for this dark matter and reveal the mystery. So you see how in order to do that, in order to tell an experimentalist and therefore the industry why it is useful to do it, theorists like me have to really work very close with someone like Oliver even, with Oliver, and certainly with Norbert and Achim and other people in the field, to co-design these experiments. So co-design is at the heart of what we should do together. So this is an example from my, you may think particle theory is so far away. So as you see, it's not so far away. So Norbert, you are a real pioneer in developing many quantum information-based areas. So I would like that you tell us how is your feeling of the role of basic research into practical applications, please.
Yeah, thanks. Yeah, I think one important question is always the question of time scales, right? We do basic research and then we look for applications. And the question, how long does it take? How deep does it go? And I think it's very important for us, and I think we see that during the panel today as well, that there's really will be a lot of interaction forward and back in actually to enable that flow. But if you think about quantum technologies in the timescales, you will actually find out that depending on which field we're talking about, we will get different timescales. So I think the most short-term thing that we're actually seeing is a field called quantum sensing. And this one uses basically the experience that we collect for trying to build quantum computers, where we really have to harness systems at the quantum limit. And we can use this one over here now to sense magnetic, electromagnetic fields, gravitational fields, and just to use this one, because all those fields appear while we try to build the quantum computer, they appear basically as something which makes, gives us noise in the system. So we fight it. But the good thing is basically, if you don't find it, then it becomes a really good sensor. Right? You see, oh, there are fields around, let's figure out what it is. But as well, the knowledge in that area, indeed, already today starts to contribute to things like medical imaging. like MRI applications that we've seen, there's companies around that actually use this one over here to get basically higher resolution MRIs in shorter time. As well, optical imaging, right? As well, imaging your eye is another thing which is very important in sensing, where quantum technologies play a role. And part of it is, of course, you don't want to really shine strong laser light into your eye. You want to go with weak signals, so it's easy to come into the quantum domain, right? But as well, gravitational field detectors is something when you try to look actually for oil deposits and really to analyze what is in the ground, you look for basically density fluctuations. You need high precise measurements of the gravitational fields. So these are all very important parts, and that is something that we see already today. We can start to include this one into our products. I think the next one in line is quantum communication, and especially quantum key distribution. And you will be familiar, this is a very important topic here in Germany, right? And it's in Europe. There's a big activity called EuroQCI that want to have basically secure communication based on quantum effects, basically covering all of Europe, and there's basically all national projects actually to contribute to this one. And that might be free space, might be fiber going to satellite and so on. So that is something I think where we see as well, that is on its way to the commercialization, right? What we really need is for that one as well to go through certification and to really have these kind of steps.
So Norbert, you say commercialization? I'm sure the people here are very keen on knowing more about it. Can you go into that?
Right. Okay, for commercialization, we see already, for example, and you see this as well here in the stands over, quantum key distribution is really something that will be used, because we need to become quantum safe. Quantum computers threaten actually our infrastructure that we have today. And so there are companies that build these QKD devices. But the thing is as well, these things need to be integrated in our all overall system. So there's a whole ecosystem of companies coming up that actually now translates this one into true solutions that can be actually adopted by the industry. And so we have in Canada, we have for satellite QKD the KeySat project that takes the lead over here. There as well as I said, satellite QKD projects over here. This morning there was a presentation as a DLR stand over there, mentioning as well 2 satellite projects going on there. And that is as well one area actually very important for collaboration, because especially for satellite QKD, you want to go make sure that the satellites and the various ground stations actually can actually talk together. So these are basically companies, especially in the quantum safe space over here, that indeed are emerging, and indeed both in Germany, in Europe, but as well in Canada, where really customer base by now in the area of quantum safe is actually emerging. Right?
Thank you. So Achim, you seem very relaxed there, so let's go to you. Since the early 90s, I'm sure you heard the buzzword Shor algorithm. So we are trying to develop quantum algorithms, and the idea is to try to understand how good a quantum computer could be with respect to the very powerful quantum computers we have, classical computers, sorry, the super classical computers we have today. So, so this definition that we have heard a lot about, quantum advantage is really comparing the very strong classical computers, which are related to quantum computers. So, Achim, so what do you think are the promises for a quantum computer, and what are you thinking are the challenges we are facing today in building a quantum computer that could actually basically have a quantum advantage, so that can be stronger to solve at least some problems, some problems we have in the real world?
Right. So regarding the first question, the promise of quantum computing, I think the promise is not simply that these computers will be faster. In fact, for small problems, a phone is probably always a better computer than a quantum computer because it's much cheaper to just use a little computer. The promise of quantum computing is not the speed, it's the scaling law, it's the scaling behavior. How much do we need in terms of resources, time, energy, money? How much do we need in terms of resources as the problem size increases? And there, quantum computers have the potential to scale much better. And that also means, for example, that it can well happen that a problem can be solved by a quantum computer today, and it can be solved by a supercomputer. But maybe the quantum computer is already cheaper. It's not only about speed. Now, your second question, what is the bottleneck? Why don't we have big quantum computers already? And I think the issue there, the fundamental issue there, is that we have two seemingly contradictory design objectives. One design objective is that we need individual particles, elementary particles such as photons, electrons, atoms, ions. We need them to interact with each other in a very controlled and strong way to perform a calculation. But at the same time, we must make sure that they don't want to interact with anything else because that would mess up the calculation. And so this need to have them strongly interact, but only among each other in a controlled way and with nothing else, that is very difficult to achieve. It's a little bit like trying to herd a number of cats. The cats want to go anyway. You can't do cat herding, right? And so what is the way forward there? I think the way forward is becoming clearer and clearer. It's not trying to build huge quantum computers because it would be like herding 10,000 cats. You can't do it. It's probably going the way that we're going to build small quantum computer modules that have perhaps 100 qubits, but 100 qubits that are error controlled, that are logical qubits. And if we can build such a unit once, we can also build it 1,000 times. And then we can link up these units, these modules, with quantum communication so that they then form one big functioning quantum computer. And notice that this means a nonlinearity in the timeline. Because it's not like we slowly creep up the number of qubits from 50 to 100 to 200 and so on. But once we have reliable modules of 100 qubits, we can build a lot of them and then link them up with quantum communication.
So, thank you. And so the important point that I caught there, besides your recipe for building really strong, big quantum computers, is quantum communication. So quantum communication is communicating with parties that are far away. And so there is one option that is using quantum communications to make a big computer. The other option is how to communicate far away. And I would like to ask Norbert, who has been thinking about this a little bit, how we can deal with the fact that when we want to communicate across distances, there is the possibility and the certainty that will be a lot of noise in the process of communication. So how do you see we are evolving in the challenges that involve the noise that is in between different ports in quantum communication?
Yeah. The moment we start to talk about networks over longer distances, we encounter a problem that in the example that Achim gave, we just connect locally some processors, does not exist there, but you go over long distance, the first thing is loss. Typically the carrier that we're using is light, something like a laser pulse or whatever thing it is, and you send this one through an optical fiber or with a telescope in free space to the other location. The main effect is just loss. That means your photon might not arrive. It's very bad if you do quantum communication. Now in classical communication, there's a simple thing. You take your signal and then there's a box called optical amplifier, and then your weak signal becomes strong again and you continue going on there. Unfortunately, those devices don't work for quantum signals because they act like a measurement. That means there are no quantum effects surviving this amplification. For classical communication, good, perfect. We know how to master it. But we need actually now to find new devices in which we can play the analog role of this optical amplifier. How can we regenerate actually signals? And that is basically our quest, what is called quantum repeaters. Right? How can we go over long distances so that we really put global networks in there? Now there's basically one thought in there, basically how can I build a quantum repeater? And that is basically if I have lost signals, you can do another method that you would recognize is error correction. Right? If you take a signal, some signals get lost classically, we can use what's called an error correction code that survives, so that information survives even if individual signals got lost. Now we want to do this one as well for quantum signals, and then this area is called quantum error correction codes. The thing is a little bit trickier, right? And the one trick comes, of course, because what, as Achim said, in quantum mechanics, you cannot just copy information. Classical codes very often look about, oh, I just sent it a few times in a smarter way, but you send it a few times and then one comes through and you're fine. That principle does not work for quantum information, so we need to find a different way of doing that one. But that is for sure an area where we see basically in the how basic science now is actually has to work very hard to figure out how can such a box look like. But it brings at the same time as well the interaction in there between basic science, where we think, oh, abstractly what could be built, and then there are people who are actually building boxes, and as a theorist, I can write something on my whiteboard, and I show that one to the engineers, and they topple over laughing, well, because this does not work this way. And where you really see you have really this kind of learning process about conceptually how to think about something. That's what basic science brings in. And then there's application part about saying, what is it we really can do? And now both sides have to move. Right, until you come to the part where you have the overlap and you actually can build it. Right?
Thank you, and we are working hard in that direction. That's true. So we are. I hope you are getting the message that whoever. So Oliver, you are interested in the application-oriented development, and we are trying to get the message that we basic scientists, basic research, are really useful to you in that process of application-oriented development of quantum computers in this case. So I guess that you are working on quantum computers, and you are representing, as we heard before, the Fraunhofer Institute for Industrial Engineering. So I would like to poke you a little bit on telling us more about how you see that basic research can really help the industry partners, how your institution is linking both ends of their long rope.
Okay, thank you very much for that brilliant question. So I would like to link to Norbert a bit, because you gave me, let's say, a ball, and I can shoot it now. Quantum sensing is a very good example where basic research years ago did the foundations for what we find now in industry. So quantum sensors are in application. This was a sequential process. So we got quantum sensing in theory, then somebody gave it to applied research, and then somebody gave it over to industry, and now we have it, especially in production and in many other applications, in place. So this time we would like to be a bit different and have not a linear approach. I would say it's a high-dimensional matrix I would like to work in with basic research, because right now we see that quantum computing will be available hopefully soon. We all cannot tell when, but we know if it's there, it will be a dramatic change. And this change could be driven from the application side as well. So we can formulate from the application side and from industry what are the needs. And some of these needs have already been spoken about, like security application. So what's about if your quantum communication comes in place, then we have to talk about security applications. And this RSA algorithm we use in these days will not work anymore. It's the same problem. So what's about solving large problems which are not faster but which consume a lot of energy, like fluid dynamics? And Achim talked about that these applications might run on quantum computers on a very low energy level. So what about searching into very large data structures, optimization problems like routing? So these are all applications which come from industry and from application. So we would like to look together with basic research on the end-to-end quantum advantage. So not only basic research, but the application as well. And it's on us to formulate, sorry for that, real-world problems which we can solve with basic research and the industrial transfer of both quantum sensing, quantum communication, quantum computing. And on the other hand, we see a role which have we to play together with basic research. And sorry for that, Akim, taking all your sentences, translate them to normal people in industry, that they understand what's the difference between normal 0 and 1 computing and what quantum computing brings as an advantage, so that people know what it will bring to their problem world and they can formulate it in the right way.
So thank you. So this putting all together clearly is a massive task that is ahead of us. And so I would like to poke a little bit more on how these pieces that we are putting together are intertwined. So how in practice basic research is digging deep and helping the technological end, and also the other way around. As a theorist, as a basic researcher, and I will share that later on, there is real good examples where what is found through technology applications fits back in what theories learn and the discoveries that theory can do. So maybe Norbert, you can tell us a bit more, what is your vision of this intertwined structure between one end of the chain, of the innovation chain, and the other, and how they feed back into each other?
Yeah, and indeed, basically, as you said, for quantum sensing, it was a little bit more linear. But we don't expect in the other areas to be exactly like that. And I can give an example from quantum key distribution, where you see that this one is not a linear process at all. So quantum key distribution came about in 1984. Right? So that was the first time it came out. And it was basically coming out from the hippie community of physicists who thought about crazy stuff, right? And so there was a crazy thing, because in quantum mechanics as well, if there's a signal coming and you try to measure it, it's changing, right? So that means the funny thing, the effect over here, you look at it, you grab it, you change it for sure. That means, oh, when sending a signal, I can figure out whether someone looked at it, which is very different from classical world. So that is basically what the physicists thought, and said, oh, can I do that secret messages using that effect? But they didn't get anywhere because they were trying to send direct messages. And then that physicist actually, while swimming somewhere in the sea, encountered this computer scientist who happens to be Canadian, Gibraltar, and just told him about this crazy idea. It's hard to picture that one, but it's while swimming out there. And then the computer scientist first told him, look, because you do it wrong, you try directly to send a message encrypted to the other side. Of course, conceptually will not work. Try first to make a key, and if that one succeeded, no one touched the key, then use it for encryption. That is the part how quantum cryptography came about. But that one was basically, of course, at that moment, completely theory stuff, right? People just, had a good beer, and then you talk about this kind of things. What does it have to do with practice? Well, incoming engineers and say, oh, what you want to do is a two-level system. Photon and polarization does it. I don't have a single photon source. Let's use a laser pulse that approximates it. And then people were doing the first experiment really coming from optical communication engineering. But then comes the question, is that really secure? In which sense? And you had to whip it back to the theory people to say, look, this is the stuff we can do, which is not what you told us to do. And then theories have to develop additional tools to say, oh, with laser pulses, I can do it as well. So it goes back into engineering. Now we do it with laser pulses, right? But now the thing is, now we do this in a lab. Now we go in commercialization. And now the part things, is that true what we are saying over here? Because everything depends on the model of our devices. And then things come in. We talk about certification. What are the side channels in what you're doing? So suddenly we say, oh, sidechains, our devices might not operate exactly as we are thinking. What does it mean for this fundamental security that we are promising? And then say, okay, good, we need to send it back to the theorist to say, look, you need to come up with ideas that are actually tolerant about these kind of fluctuations, right? So you see, it's a forward and back. Basically, I started in that field in 1993. I'm really glad I did not know about all those difficulties when I started, because I probably would not have started. Sometimes you learn those things in increments, and that is the only thing why you're actually doing it, right?
Have the guts to do it. So I am jumping ahead a bit because I think we are short on time. But one of the things I want to share, from my own institute that I think is exciting, very exciting, related to this, two-way street is. So some of my colleagues have been who work in what is called quantum matter and quantum information. So most recently, it has been learned from the very basic research side that they are what we call different phases of matter. And what it means is that basically we have understood that there are some properties, some macroscopic properties of matter that we can understand by what we call the patterns of entanglement. We have not heard that word today yet in this panel. Entanglement means that, at some level, a system of particles is not independent of each other. And if I am here as a particle, I still know what Corinne there is doing as a particle, although we are not communicating. That's amazing. That's mind-blowing. And that's quantum mechanics. So quantum mechanics means I can communicate with you, although we don't have any link or my phone to know where you are or whatever. So they realized that, as I said, properties of matter are deeply connected to entanglement. Quantum information is learning about entanglement, and putting it together, it means that I have learned about properties of matter, basic research, and with that, I'm able to use that behavior that I have learned related to entanglement to then build what we call logical qubits, which means we build codes which has this error correction that Norbert was talking about. So we can correct the errors. And so quantum matter basic research is working now with industry to try to make logical qubits that have these amazing properties that they have discovered in phases of matter to build basically codes that are error corrected. And I think that's mind-blowing for me. And this is my colleagues, on the other side of the corridor at PI. So I have many other examples, but I don't think we have 5 minutes to go. So I don't know what I'm doing. I want to say all the things, but I should not. So one quick question to Oliver. So what is exciting for Fraunhofer and for you about working with us in Canada?
Okay, now I feel a bit of pressure from left and right and from front, from Paul as well. But it's kind of easy. So as I mentioned before, Fraunhofer Society in total is working exactly on that place to transfer basic research to applied research and bring it to industry. So what we always do when we look for basic research partners, who is the best? And where we can get all the knowledge from. And that's why I look to my right. IQC, it's a unique jewel on this planet. And if I look to the research Achim is doing, that's unique as well. So that's why we have chosen to work together with these two gentlemen in the institutions. And even to the Perimeter Institute, which is really, really far away from our, let's say, field of work, we had a visit to see what they are doing. So we try to get the best partners to solve problems, and especially the facilities you have in Waterloo, it's amazing. So we don't have that in Europe, not at all. And the research you are doing, Achim, and you mentioned the paper you have disclosed us in last October a bit, and we love to implement that. So we found very good partners, and that's the reason why we see that's a pretty good collaboration. We can contribute a bit to it. We have the industry questions, we have a network we can play with, and to bring basic research as fast as possible, not linear, but in the kind of a high-dimensional matrix to work. And that's the major reason.
Thank you. So I have to say that Perimeter Institute, together with IQC at the University of Waterloo, are seeding and leading the quantum ecosystem in the Ontario region and connecting across Canada. And so we are delighted to our prospects, our current collaboration, our further prospects to collaborate with Germany and with Fraunhofer. So maybe the almost last, whoever can get their word in, Achim. So risks and opportunities of the quantum revolution.
I think that there is...
in 1 minute.
1 minute. I think we have, at the moment, a historic opportunity because of the events in the United States. We've had decades of brain drain from Europe and Canada to the United States. If politics, academia, and universities in general get their acts together, I think we can reverse that brain drain to some significant extent. And I would very much recommend that.
So I think in this forum, this idea was mentioned many times, so we are all thinking very much about it. So, gentlemen, minus 1 minute each of you.
No, I think it's very important that really quantum information and quantum technology has so much opportunities. It's really important for us to harness that one. And that is really to make sure that the word goes out, what the opportunities are and how it will change what we are doing. I think that is something we should compare to what happens with AI. Right? There is a completely new way of doing things, and that is coming up as well in the quantum world over here. The way how we process information, how we secure information will change, and it's very important to have the awareness around it.
So -1, we are here at the Hannover Messe of Industry, and I like to highlight an industrial opportunity. So we already worked on quantum machine learning algorithms for industry, and you have one customer who benefits already from quantum machine learning to predict prices for used equipment on construction sites. Normal computing is not able to do so, so that's an opportunity, and I would like to ask everybody here to be an early adopter and to call in to what we are doing both in basic research and in applied research.
Thank you. So I think we are basically out of time. I think there are many topics that we have not touched upon, and I would love to, so come tomorrow. No, I'm just kidding. So I think that the frontier of what AI can do for quantum, and maybe the long future, what quantum can do for AI, is a topic to be discussed. And I think the cooperation, from my point of view, the cooperation of the different areas of the innovation quantum ecosystem, I think is our strength, our power, and our opportunity. So without more there, I would like to thank Norbert, Oliver, Achim. I would like to thank you all for being there and being, I think questions are for afterwards. I'm sorry. I hear that we are not allowed to ask for questions now. But I would like to thank you, the organizers of the Canadian Pavilion. I would like to thank you, the hosts of this amazing messe. And just to finish, I would say what one of my colleagues from Canada told me yesterday. Says, this place is great. I feel already at home here. And I think that's, I will close with that. We are all, we from Canada, we are all feeling at home here. So thank you.